Ladies and gentlemen, welcome to the PK stream with my friend Marc D'Antonio.
La 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 la.
What is up, everybody? We were sitting here talking shit about all you behind the scenes, just so you know.
That is not nice.
No, we weren't doing that.
Not at all.
As you can see,
Keith
Jupiter's
tried.
on stream.
I wouldn't let him.
Yeah. He put his foot down. He said, "No, you stop it." So, yeah, as you can see, Jupiter's on stream. It's looking pretty good tonight. Saturn is coming up. So we're kind of just hanging out. I'm still waiting on an email back from Amy. Stupid me. Totally forgot last night to email her. So I emailed her at 4 o'clock this morning. And I'm hoping that maybe she sees it last minute and says, "Hey, oh yeah, I'm free." Fat chance. But I am monitoring the email just in case it comes across. So...
no worries.
No worries. We do have a couple, Paul said there's a couple puffy clouds roaming by, but they won't last long. They're on their way out, so we should be good.
Actually, Paul has his anti-cloud gun. He's going to just shoot them out of the sky.
He is going to shoot them. Very much so. So, what do we got? Today is, what, the 24th of June, 2017. Wow, we got 2 months. And we're looking at a solar eclipse.
That's right. And that you're going to Nashville, huh?
Yeah. Yep.
Awesome.
And there's a good chance that you're going with us. You just don't know it yet.
Oh. You know what? Okay.
There you go.
Actually, I was telling Keith earlier that I actually have to drive an observatory dome down to Knoxville. And I was looking for a way to get it down there, and I figured I'm just going to drive it to make it easier. And I guess why not go in August when the eclipse is, so I can actually drive to Knoxville, spend a few days at the school where I'm dropping off this dome for them. That's a donation. I'm donating this dome to them, not the one I'm in, not the one we're, I'm in my dome too, by the way. And then I'm going to drive over to where Keith and Paul are going to be, and we're going to watch the eclipse. And we're going to check that out.
And we will be on top of a skyscraper filming the eclipse. I'm going to have one camera actually on the eclipse. And then I'm going to have actually another camera of the skyline of Nashville, actually, so I can catch like a time lapse of the shadow cover. Now, knowing our luck, the way things just happen to go for us, we'll get there to Nashville, and there'll be like a rainy, monsoon going on. But I think we have what? We have a 350-mile swath where we can play.
Yeah,
for 100% totality.
Yeah, and you should be able to plan that, about 4 to 6 hours ahead of time.
If not
and
a
just
day
kind
ahead of
of
time. Because if I see clouds moving, I'm like, dude, we're going west another 4 hours.
That's it. You end up out in the middle of the sticks somewhere. And,
that's fine. I will party with some hillbillies to get some solar footage.
As long as you don't mind giving them your telescope, they'll be looking in the wrong end the whole night.
Just hear me out. Bring your Clem stuff just in case we have to relate. We'll send you up the hill to talk to them. You get us the okay, and we'll do what we have to do.
Yeah. Clem Puckett's from Reeves, Louisiana, so I don't think he's going to have a whole lot of pull with his, with the Kentuckyite type folks, down there. But hey, right. There's always a chance, isn't there?
And just to update, I have not heard from Mr. Walson about
coming
on or anything. So just update you there. Haven't heard a word from him yet.
Yeah, hopefully he'll come around, because if he's really got a novel way of showing things at such magnifications, that's great. But I did send him 4 questions. One of the questions was, if you are looking, he said these things are stationary in the sky when you're looking at these satellites in the sky. If that's the case, that means he's got to be looking at the geostationary birds. And if he's looking at the geostationary satellites, that means they're 22,000 miles out. So if they're 22,000 miles out, that means that he should be able to take that same technology, and if he aims it at the moon, he's going to get far higher resolution and views of the moon than he currently has been showing. Right. So I said, this is a contradiction, and I want to know why you're not using this extreme telephoto technology if it really exists. And right now I'm just, I don't say it doesn't, I don't say it does. I need to have it shown. And if it really exists, then he should be able to get these, unbelievable views of the moon.
And the one point I want to make too is that not only that, but if they do turn out to be satellites, don't get us wrong, they are amazing imaging of satellites. They're probably the best we've seen. So if they are satellites, there is still a path to go down, with some professional people that are actually into imaging passing satellites, whether they be military or regular satellites. Once again, I was talking about Theory Galt earlier with you, Mark.
Yeah,
and that's what he does. I mean, he tracks satellites, and I've seen some of his images, and they look exactly the same as John's, but John's, believe it or not, are better. So if it is in fact a stationary satellite, he's getting better imaging than the person known for doing satellite imaging. And there's a way, you can get John hooked up with him, or, however you want to do it. I mean, there's successful paths to take, if it is in fact satellites.
Yeah, and I think it'd be worthwhile, because the bottom line is, that technology is something that, should be available to anyone who can do it and who wants to do it, because imaging like that is a rare capability. So it's good to be able to do that if it's in fact doable.
Right.
So the jury's out for me until I see some more proof or some more evidence. I'm gonna not make any more judgments of it. I'll just, if he doesn't want to come on, then that just always looks a little, that looks a little shady. You know what I mean?
And once again, there is an open invitation for Mr. John Leonard Walson to come on if he wants to. So we will leave that at that. Besides that, wow, what a picture he's got going on with Jupiter right now. Wow. I'm not sure if you're seeing that, Mark, but
I'm actually seeing Jupiter on my screen right now that I am streaming. I'm not streaming it, though. I'm just showing it. But I'll just pop over to his and to your site for a minute to see it.
And once again, while we're waiting for Saturn to come up, if anybody has any questions for Mark, feel free to ask them. We'll try to get to as many as we can, because we are going to be talking heavily about Saturn in a little bit once it does come up and start showing its face.
No, it's up. Now, it's just Mark, little low.
some of the people in the chat might know this, but last night I had the benefit of downloading Astronomy Sandbox 2.
Oh yeah.
Okay, have you played this yet?
Oh, I have it.
You have it?
Of course. I mean, Universe Sandbox.
Yeah, Universe Sandbox. What do you think of the second one?
I think the second one is kind of a leapfrog over the first, because the second one allows you to do more mouse click maneuvering and change. Now, what he's talking about, this just imagine if you had a sandbox, a playscape basically, where you could create and destroy anything you wanted in the universe. Build planets, see how gravity interacts with large stars, with small stars, make stars collide, see what happens. This is out there, and it is called Universe Sandbox, and the second version is out now. The first version, which I also have, is really nice, but it's a little bit more tuned to someone who's more knowledgeable of the universe, and the first one is, and you have to be able to know the parameters, and you want to put in some parameters.
Right, and the first one was basically, I mean, for all intents and purposes, it was a gravity simulator. A hopped-up gravity simulator. It was kind of bound by its own thing, but it was still awesome. Whereas this one, there's a lot more involved where you can simulate weather. You can literally watch planet Earth and take the average global temperature up, 1 degree Celsius, 2 degrees Celsius, and see what, the effects would be over time with, like, lakes drying up. And you can, if you want to, if you're the destructive kind, you can take Jupiter and slam it into Saturn and see what would happen. And it takes all the physics involved with it and all that kind of stuff, and it shows you what would happen if something like that actually did happen. Now, last night I was playing around with it because I was talking to Daza, and, he's big to the Nibiru debunking and stuff, and I was like, well, what would happen if I took this brown dwarf planet and brought it into the solar system?
Mm-hmm.
So I stuck it outside the solar system. I stuck it out, past the Kuiper Belt, and all that, way out there. And even way out there, it had very major effects on Neptune. And once again, I made this like it was a brown dwarf, like a pretty big brown dwarf. But
a brown dwarf is at least 80 times bigger than Jupiter.
Yeah. So I mean, I think I went like. I think it was like 120 maybe, but it started to show, even at huge distances, it started to show the pull on Neptune and Uranus, and and then eventually my orbits of all my planets all the way down to Mercury started getting skewed after like 1 million years or so.
Mm-hmm.
So it's like, okay, we would be able to detect it, and then I brought the damn thing into the solar system.
And you watched everybody
that didn't
just
last
going
long.
Like, hey, let's have a party. Let's go see that brown dwarf.
Because of the sun, it started speeding up. So once it got around, Kuiper Belt, it started just speeding up. And the next thing you know, I got planets just smashing into it. And then next thing you know, it went into the sun and created this, like, it was just absolutely nuts. But
well, did you actually create an orbit? Or did you actually just set it out there and have it not moving? Well, I initially
created an orbit for it. It had a very, very huge orbit around the sun. And then, me, I just had to play around, and I just, targeted it for the sun, and I sent it through the solar system.
Not you.
And the thing went in there, and it just was like a bowling ball and bowling pins. It was just like knocking things all over the place and pushing things away and pulling other things in, and then all of a sudden you get the fast, what they call the wraparound orbit. Where things speed up.
That's the slingshot. It's called the slingshot, right? The gravity whip.
And next thing you know, you had Jupiter slingshotting around and firing into Earth, and then it was like utter chaos. And literally that part of it, our solar system only took like 4 months for it to totally destroy our entire, because it kept speeding up as it got closer to the sun. So, but yeah, if you guys want to check it out, definitely go get it. It's real cheap. You can get it off of Steam. I think like right now they're having a special. It's like $16 or something like that. So if you want to have fun and you have a computer that can process the graphics and everything like that, I mean, it does have some requirements for it, but if you have a computer that'll do it, it's definitely a lot of fun. You can just, I mean, there's so much involved with this new version of it. I mean, everything from colliding galaxies together.
Yeah, that's what I was going to say. You can also do, more than just solar system objects. You can actually create a colliding galaxy if you want, and show many stars and how they go through other stars and how they actually interact. And in our streams, with Sky Tour live stream, we actually show galaxies that are interacting with each other. And I want to eventually show that in real life, so we can actually see what it actually looks like in real life. And then it might be really cool to have the simulator and actually show that in the simulator.
Right.
Because you can recreate the galaxies, like for instance, these are called the antenna galaxies. You can recreate them in Universe Sandbox, and
you can make your own solar systems too if you wanted to.
Yeah, you can. You can explore exoplanet systems. You can create a TRAPPIST-1 system, and see how these planets would in fact be all within the orbit of Mercury and how they would interact with each other.
And I will say, cool. Paul just messaged me. He just wanted to let everybody in the chat know hello, and he's hoping for a good night tonight. He said he did try some deep space last night, but he said there was nothing good till about 4 a.m. So that's how we go there.
By that he means Andromeda Galaxy, because that didn't, that shows up late and then high in the sky, and not until then.
Okay. So we got a beautiful Jupiter. So I guess we can talk about Jupiter a little bit. I mean, we've pretty much said everything we can, but I'm seeing a lot of new faces in the chat. So let's get the questions out of the way first and foremost. Why is there banding on Jupiter?
Well, Jupiter is actually mostly hydrogen gas, but what you have with Jupiter is a small percentage of the composition is actually impurities. A lot of ammonium compounds, and these compounds actually will look a little bit brown, and so these impurities actually make the bulk of the color that you see, and it's pretty cool, because it doesn't take much. It doesn't take much at all to make the banding, and that's why they look brown. The brown is that specific color, that you actually see. With this particular this stuff, and in terms of what that actually is, Jupiter has like I said, a molecular hydrogen that's diatomic hydrogen H2, and a little bit of helium, but it also has ammonia, like I said, nitrogen, sulfur, and methane, I think, yes, and then other hydrocarbons. Okay, but when people say, for instance, Jupiter was a failed star, that's another thing that I have to address, because it's not a failed star. That's like saying Earth was a failed super Earth. It makes no sense. But the thing about these clouds, right, the ammonia ice clouds that are brown and made of these hydrocarbons, they actually tend to move in opposite directions when they're right next to each other. So say like the white clouds, the white bands are moving one direction, the brown bands in another, generally.
Yeah, but if you take Earth and flatten it out on a flat plane to view it and view cloud formations, Earth does that as well. We have the lower, going west, and then we have the middle going east, and then we have the upper going west again. So it's like, the cloud patterns, the winds of change.
Yeah, but Jupiter being, almost 90,000 miles across, the border, it's going to be huge. It's great. The cloud bands are actually. Oh boy.
Go ahead.
Yeah. Okay. Yeah. But the cloud bands, they seem like they're so discrete and separated by this tiny little bit, but they're not. They're separated by hundreds and hundreds of miles. They're blending, I should say. There's a blending zone of like hundreds and hundreds of miles between them, and there's all kinds of turbulent eddies between the two. So it's actually just this massive maelstrom, I like to call it, of swirling, turbulent clouds, thunderstorms. There's a lot of lightning on Jupiter. When probes have gone on the backside of Jupiter and actually see the storms, Juno's caught storms and lightning flashes in the upper atmosphere. This is really incredible, and these cloud bands can move up to 300 miles an hour. Which is 150 meters a second. That's fast.
And you're talking about a planet, with a 10-hour rotation. Yeah. So it's like that is absolutely for a planet that size, that's just amazing. It is. You're right. That's a massively large orbital or massively large planet to have such a small orbital rotation, which means that Jupiter is not perfectly spherical. Okay, it's going to be a little bit distended at the equator and a little bit oblate from its rotational velocity. Mm-hmm. Massively.
Yeah, well,
compared to, what did they say? I know we looked this up the one night, but wasn't it like a 14,000 or 14% from the poles? Because punishing out on the middle, it's like a 14% oblateness or whatever it is.
Yeah, that was actually Altair. I think we were talking about a star. I think
Oh,
we're
I
going
thought
with the
that.
star.
Yeah, that's right. I'm getting the streams messed up.
Yeah, no,
That was
see,
on yours.
rapid rotating stars, the way we actually know that a star, for instance, is a rapid rotator is by looking at the spectral bands in the star. We can actually detect that the lines look different from a star that's not rapidly rotating, and we can actually use that difference in the lines, the spectral lines, to actually determine how fast it's going. Similarly, with a planet, in a planet that's moving like Jupiter at a rotation rate that it's moving at, we can visually see how fast it rotates because we can track that with no problem.
Right.
So we don't have to go through some big study to actually look at any spectral lines. Now, Jupiter does have spectral lines, and the question is, does anybody out there in the chat know what they're from? It's still your turn.
Yeah, we'll give you a hint. It's not China.
And it's from something huge.
Huge, massive.
Yeah, incredible.
Yeah.
So so let that gel on you for a while. Jupiter does show spectral lines, and
you know what? While they're thinking about that, let's talk about the fact that Jupiter now has 69 moons instead of 67.
That's correct. Jupiter now has 2 more moons that have been found. And those 2 moons are like rejoicing. They're happy. Yay, we're somebody now.
We're not pieces of rock anymore.
The new phone book's here. I'm somebody now.
Yep. And now most people, of course, when you look at it through a telescope, just like when you see it here, you're going to see the 4 big Galilean moons, okay? The Callisto, Io, Ganymede, and I'm missing one.
You're talking about Europa?
Europa, that's it.
Kind of the big one.
Those are the ones that you're going to see when you overexpose Jupiter, like you see Paul doing. Like when we're actually in on Jupiter and imaging it, you don't see the Galilean moons because of the fact we're focusing on Jupiter. So we got to take the brightness way down so we can catch what you're seeing, the bands in Jupiter and everything like that. But when he overexposes it, in terms of basically, in layman's terms, turns Jupiter white. That allows him to actually see the Galilean moons orbiting around. And believe it or not, we've had nights where we watched Jupiter for 2-3 hours, and you just see those. And when we see transits, we've seen the shadow transits of it. I'm pretty sure we're going to actually probably see 1 or 2 tonight, the way I'm looking at the orbits. So we might have a transit or 2 tonight. And then the storm should be coming around, I believe. I have to look it up.
In 6 seconds.
No, I'm thinking around 11:30 or so, but I'm not sure. So, and then if we're still on, we'll actually see that storm, transit the entire face of Jupiter. It doesn't take that very long.
No, it doesn't.
But by then, we'll probably be on Saturn.
Yeah, that's right.
And talking about the beauty.
Let's talk about by the way, those 2 new moons of Jupiter, because we didn't, because there was more going on.
Tell people about that. I'm going to refill my drink while you're doing that, but I'm still listening.
Okay. Yep. The reason that they were found has to do with what serendipity. It was by chance. They weren't looking for them. They were actually doing a study to try and find Planet X. No, not Nibiru, and not the killer of the solar system, but just a large Kuiper belt object. The belt of stuff and debris that's out past Neptune. There's a lot of stuff out there, including a planet that may very well be as big as the Earth. Now, while they were looking for this Planet X, they actually found these 2 new moons. Now, the moons are being called S2016J1 and S2017J1. Okay, and they'll have formal names soon, but the interesting thing is they're actually pretty far away, from Jupiter itself. All right, they're actually 13 million miles and 15 million miles, respectively, from Jupiter. So these are way the heck out there. All right, and think about it. Jupiter's gravity, the force of the gravity Jupiter has, is strong enough to hold those moons. So you can see that Jupiter's no slouch. That's why when we look at Jupiter and we see this massive planet in our solar system, that's why it was able to clear comets and asteroids and other debris from coming into the inner solar system, which in effect, gave us the chance at life. So this is something that's really interesting about those big planets. It's like that, and we have 4 of them. We have Jupiter, Saturn, Uranus, and Neptune. So they acted like shields, basically, in the outer solar system, preventing big stuff from getting all the way into us. Now, so those 2 new moons are there, and then while that was a serendipitous, discovery, but in addition, they also found a number of lost moons that they thought they had seen and thought were there, but had lost track of and could never find again. And these were, they were discovered way back in 2003. But, their exact orbits weren't known back then, so they basically said, all right, well, if we get some more information or if we can get funding for a study someday, then, we'll find them again, perhaps. Well, now they did, because they were looking for Planet X in the Kuiper Belt. So, they were still considered lost all the way up until 2016. And there were 14 of them that were still lost. So, what's interesting is this is now a case where moons that we knew were there but didn't know their orbits have been reclaimed, so it doesn't add to the count. But we now have the 2 new ones. So it's really cool to see this. It's really neat to see how, astronomy advances. But the fact is, Jupiter's in our backyard. Mm-hmm. And we're having trouble finding, looking at the atmospheres of a distant planet around another star. Yeah, it seems like if we can even know that there's planets around another star, it would seem like we should be able to detect all the moons in our own solar system, right? That's how, mentally you think that. But the tasks are so different. They're very different tasks, and it's very different technology. But
speaking of tasks, it's the exact same thing where people say, well, why don't you just point Hubble at the moon or, stuff like that, because it's meant for a completely different task.
Right. I mean, they could, but, Hubble's primary mission is not the moon. Mm-hmm. And it costs money to turn the telescope toward the moon. Yep. And Hubble, they basically are on a shoestring anyway with Hubble. They don't have millions of dollars to blow on. Hey, let's take a look at Copernicus crater today.
Yeah.
Or let's look at Pythagoras and see if that's really a gun in the center of the crater, a big mortar, because everybody knows the moon has aliens that fight each other and have big mortar fights,
Because guess what? It takes some sort of thrust to move that big thing up there. And when you run out of that, guess what happens? There's no more moving.
You're funny.
It's a spaceship.
Yeah, yes, that's exactly right. And it's hollow, don't forget that.
Yeah,
it's also
So now we have Saturn on screen, and boy, is she
awesome.
Gorgeous even for still being low in the sky.
Yeah.
Nice job, Paul.
Yeah, he's doing a great job. Look at that, huh?
So, Mark, go to town, buddy. Let's learn about the mystic planet of Saturn.
Well, there's a lot to learn, and I guess because we don't see any moons right now, we'll just talk about Saturn, I guess, because
let's talk about the actual planet itself, and then we'll talk about the rings, and then we'll talk about the moons.
Yeah, no, that's fine. When we look at Saturn, okay, we notice it has primarily this yellowish color. It also has these brown clouds, all right? And if we consider what it's made of, okay, just like Jupiter, 96% of Saturn is hydrogen, okay, H2, molecular hydrogen, all right? And there's a small 2 or 3% helium by content, all right? But then you also have methane, you have ammonia, and you actually have ethane as well. And so it's interesting that this material, along with, just like Jupiter, ammonium hydrosulfides and ammonia ices, okay, these will promote the brown color of some of these clouds. So Saturn has that. Now, here's an interesting thing. When we look at pressure on Earth, okay, it's basically the pressure on the Earth is 14.7 pounds per square inch. Okay, well, and let me just convert that. I gotta do that real quick. I want to convert 14.7 pounds per square inch, and I want to convert that to millibars because I want you to see the difference here. Let me see, millibars. Okay. I didn't expect to go down that path, but I want to do that. Let's see where it goes. Okay. So, okay, if we were to convert that to millibars, okay, it's 1,013 millibars. Okay. So that's just the pressure value. Now, if you look, yeah, math. you said math. So, if you look at Saturn's, hypothetical surface pressure on Saturn is 1,000 bars. Okay, 1,000 bars, right? So, if you think about it, that's actually 1,000 millibars is 1 bar. Okay, so Saturn's 1,000 bars on its hypothetical surface, and we're 1,000 millibars. So what's that say? That says that Saturn is 1,000 times higher pressure than Earth. That's incredible. It's crushing. It's a crushing.
That is straight out of Scanners, where that dude's head just explodes.
That was a great movie. Yeah. Yep. Yep. See, and then, folks, that's how you know that you're losing Keith, when he starts to go down those paths and say, "Hey, I love that movie." Oh
man, the day I've had, believe me, I'm absorbing. I'm about to get my second wind. It's getting there quick. That's the only bad thing, because everybody's like, "Oh, you have a great work schedule." I'm like, "Yeah, I have an awesome work schedule," but the fact is that also requires me to work Friday and Saturdays. So it's like, I mean, granted, it's great because then I have Sunday, Monday, Tuesday, and Wednesday off. But
wow,
Thursday,
you got
Friday. But
12-hour days.
Yeah, but I put 54 hours in 3 days, so it's like, ugh.
Wow. But that's crazy.
So come Saturday night, I'm beat. So when we do these Saturday night, I like it, but you start losing me around midnight. Right now, I'll get my second wind, and then midnight, 1 o'clock is when I'll start drifting a little bit.
That's okay. Because when you drift, then what I'll do is maybe I'll start streaming.
Yeah. Well, I think you should start streaming after our stream anyway. Just take this crowd, anybody else that wants to learn, and just take them and jump them over to your channel, and why not?
Yeah, if they want to. I mean, I like to do that, and I actually have refined my wide-angle Milky Way camera setup so that now it's very quick.
And I should say, for anybody new, obviously our normal people that watch this know this already, but Marc does have his own channel. It's called Sky Tour Live Stream with Marc D'Antonio. You can check it out. And what he mostly concentrates on is deep sky objects. You're looking at nebula. You're looking at star systems. You're looking at double stars. You're looking at and just the amount, just amazing. Like, he can do live exposure footage that I haven't seen anywhere else yet. So, and then he takes those images and he posts them onto a Facebook page where you can download the raw image and actually have that photo if you want it.
Yeah, that's right. And the Facebook site is the same name. It's Sky Tour Live Stream with Marc D'Antonio, and you can actually come into our Facebook site. I believe it's an open page, and I haven't posted any photos up there yet. And the reason, I've had too many clear nights. I've been streaming all these clear nights and acquiring photos. And I'm going to be putting the raw photos up there. It's going to be an awful lot of photos up there. I'll try to categorize them, and it'll be really quite a repository. But in about 6 months, it'll be probably pretty deep.
And I plan on downloading some and getting them printed out for the studio, and I mean, just amazing stuff. So if you want to learn, that's the biggest thing. If you want to learn, especially how all this stuff is done, like a lot of the imaging stuff, he's great about explaining, what kind of scope stuff to do, the differences between the cameras and the scope, different exposures compared to different, it's just, if you want to learn, head to that channel. This is an educational channel as well, but we stay more or less the moon and planets, where Marc takes care of the deep sky objects and galaxies and stuff like that. And then, of course, you have Bill, New York Skywatcher, that does the total sky streams.
Yeah, he does wide angle stuff.
Yep.
And there's overlap with all of us. I mean, I'll be looking at Jupiter sometimes when it's not quite dark enough yet to go hunting for galaxies and stuff. So I'll have Jupiter up on the screen, and then I'll have the moon up on the screen as well when the moon's up. when the moon does come up, and I've already been looking at some deep sky objects, when the moon comes up, well, you can't look for deep sky objects because it's too bright. So we either look at star clusters, or we look at double stars, or we actually look at the moon.
Oh, you know what?
So
which reminds me, Mark, I should before I forget this.
Yeah.
I did receive 2 emails from 2 different people in the southern hemisphere with telescopes with the capability to stream. So I'm going to be talking to those people, and we may, hopefully, be able to add 1 or 2 more scopes to our network that are actually going to be in the southern hemisphere. So skies that we don't see. Which will be absolutely awesome. And I told them I'd be glad to do the audio for it or whatever if they just want to do the feed, telescope feeds and whatnot. But I did get 2 emails from people. They were explaining their stuff, what they have. So, I mean, just to validate these people know what they're doing. They're not like just, some backyard 4-inch telescope or something. I mean, these are actual real that take it very seriously. I'm not saying backyard astronomy is bad. It's definitely good. Keep doing it. Everybody that's doing it. But these guys are definitely higher end amateur astronomers.
That's fantastic. See, and that's what we need.
Exactly.
So, as Keith's alluding to, we're going to be having basically a clearinghouse. We want to be kind of like a one-stop shop, sort of, for all things astronomy imaging. And, I'll be deep sky. Keith and Paul are going to be moon and planets. And Bill Skywatcher is going to be wide-angle shots of the sky. But we all overlap. We do overlap between each other as well. But there are 3 different basic streams, and they're going to be focusing, on 3 different things generally. Now Keith and I have talked about doing some really cool things, like where I'm up in Connecticut right now because I haven't moved my dome and equipment out to Arizona yet, and but in Connecticut, and I'm in here, and Paul's down in Florida, so we're in the same time zone. But it would be interesting to see the moon in my stream and the moon in Paul's stream and Keith's stream at the same time to see if we can detect any differences, because the moon, remember, is like 2,100 miles across. All right. And over that distance on the Earth, we should see a little bit of a difference in how craters near the edge, or craters in certain perspective views actually look.
Right.
And that'll be kind of cool to see and categorize, and to actually then we can actually use the differences. Here's a cool thing, and this is something that will probably knock people out, I think, and make them collapse and foam at the mouth. But the bottom line is, if we can calculate and do the measurements properly, we can actually calculate the curvature of the Earth, and actually say, oh, well, let's calculate the diameter of the Earth based on the way these craters look.
Oh, don't do that. We'd have the flat earthers attack in a minute.
Well, no, that's the whole point, okay? Because right next to your channel on YouTube, one of the other suggested channels is a flat Earth channel, and it had like 3 people watching it, and you're at 80. So I think that people kind of can tell the difference.
Dude, I would love to go off on a rant right now about flat stuff. I'm just not going to do it. I'm not going to do it. I'm not going to just.
Well, you're already tired from working, see? So
I know, and it's just so annoying.
You're shutting off your filters, and we can't let you do that.
I mean, it's like, do I really want to talk about Pythagoras' theorem at this point in time? It's like, not really. But yeah. Anyway, but the beauty of all this, what we're doing, is the fact that on this site, you'll still be able to watch on YouTube. You'll still be able to do everything that we do here now. But on this site, you'll be able to see them side by side. And it's as simple as clicking one video or the other to hear the audio of what's going on. So on certain nights, Paul and myself might be streaming the moon, and all of a sudden Marc will pop on, and he's streaming the moon, and it's like we're comparing side by side. We have our own little streams going, but there might be chances where we jump on Skype and all of a sudden we're talking back and forth between channels with us, and you're seeing both of them on the screen as big as you can see them, so it takes up your entire screen. You can actually do basically a side-by-side comparison of how we see the moon from Miami, Florida, how we see the moon from Connecticut. And then on top of that, if Bill's streaming and he decides to whip out the telescope, we might have 3 places to see the moon from. So, I'd say it's not about stepping on each other's toes, because anybody can do anything, obviously. It's about, the more eyes that we get pointed towards the sky. And if we can, if all of a sudden we see something shooting past the moon in Miami, but it didn't come across up with Marc in Connecticut. We know that that's a near-Earth object that was,
That's actually
crossing over
local.
Miami's,
Local
line
to
of sight.
Miami.
Right.
Yeah, right. And it was probably most likely a satellite.
But if
And
we
that'd be
do
cool.
happen to see a little object floating around the moon, and Marc sees a little object floating around the moon, guess what that means? That means that object is really close to the moon.
It's farther away, yeah.
Yeah,
from
because
here.
of our separation. So, and you could do the angular, and measure exactly how far it would be from between the two distant. We'll let Marc do that math because I'm not good at it. I'm not even going to
Happy
try.
to do it. Happy to do it. I'll do it.
So that's the plans in the future. Hopefully we'll have that up and running in a week or two. Until then, I'm kind of jumping on Marc's channel. Marc's jumping on mine. Bill's, bless his heart, running KGRA on the weekend. So he does some throughout the week. I hope he does more, because the other night he did a stream, and man, we just were seeing satellite after satellite after satellite, crossing, and it was really, really neat. And I'm sitting here tracking them via Stellarium and naming all the satellites that are going past. It was a really good time. So,
well, I mean, Bill has a camera that's very nice. The thing is that his camera, he got it up and running, and he's using it for his streams. And then, I go up there and they say, "Hey, Bill, do you know you can do this with your camera and this with your camera?" And he's like, "What? Oh my God! I can't believe it!" And then next thing you know, it's like now he has to do it,
Yeah.
And then I told him that I think we got clouds in Miami right here.
Yeah, you got a couple ones passing.
And then they told him about some other things that he could do, with his telescope, and again, he didn't realize it. And next thing you know, he's got to go buy this, he's got to buy that.
And not only that, but Bill has a pretty rare telescope where it's a go-to Dobsonian.
I know, that's pretty crazy.
A 10-inch go-to Dobsonian at that.
Yeah.
So you don't really see many of those.
No, and I mean, I have an 8-inch Dobsonian
I
here.
should have stole it. I should have stole it when I was there.
I actually, you know what it was? There was this little kid who he loves astronomy. He's into astronomy, but he doesn't have a telescope. He can't afford a telescope. And his father, when I was in the hospital, his father came over here and rebuilt my front deck. Now I have a beautiful home, and the front deck was actually in need of some repair. And he came over here on his own, didn't want any money, okay? Didn't even take money for the materials, and he rebuilt the deck while I was in the hospital, okay? Now, what do? You thank someone, of course you do. But his son couldn't afford a telescope, and his son loves astronomy. And it's an 8-inch Dobsonian telescope, and that's, a substantial telescope. It's a serious telescope. Well, I decided to give him the telescope, because I felt that he would benefit from it, in the short and long term. And he was just astonished, and it's like, whoa, why? Come on, man. That's the least I could do. You came over here, gave of your own time to help me when I was down, and that's one thing that I'm going to do, is I'm going to make sure that, I show my gratitude. And that's what I did, So
don't tell me that, because I'll be there like in 2 weeks building a back deck on your house or something. You'll wake up and be like, "What are you doing?" I figured you would need this back deck or something. Wink, wink.
I need a patio with a fire pit in the back.
Yeah, I heard you giving Dobbs away for this kind of stuff. Is that true, or?
Yeah, no.
Well,
yeah, definitely. Oh, definitely. Oh, absolutely, definitely. No.
Yeah.
Yeah. I came outside. I had to go inside for a little while. And when I came outside, I'm looking up, and I've got like high altitude clouds all over the place. It's like, what the heck?
Really?
Where did those come from? Yeah. So I don't even think I'm going to get the stream if this keeps up.
Wow.
But that's okay. I'm on your stream. We're talking. We're having a good time.
Yeah. Well, you know what? I think I think it is. I think it's isn't that what they refer to as daytime heating clouds? Like when the sun goes down, it cools off, and the temperature differential between the air and the ground kind of makes clouds form here and there.
It does kick off a batch of cloud formation depending on the temperature and the conditions. And
I know it doesn't like Paul. Hates Paul. Because Paul's down there and texting me, "Dude, it's clear, it's beautiful." As soon as I hit the stream button, here comes a giant cotton ball cloud out of nowhere. It's like then we end up waiting for 20 minutes, waiting for it to clear.
Yeah, that's what happens. I mean, unfortunately, you end up getting these evening clouds that a result of the warming, the warm air rising off the ground.
Well, Miami's a monster in its own right. They say about Miami,
exactly.
If you don't like the weather, wait 15 minutes.
Well, they say up here, wait 1 minute. So I think maybe,
yeah,
we got that problem. But the bottom line is that, when we look at these clouds, and I'm sure you can hear the crickets, and I got fireflies all over the place and crickets.
Fireflies just started here.
Yeah.
They're a little late this year, but they're here.
Oh, yeah, no, they're here in droves. It's just like, everywhere you look. In fact, it's like, whoa, was that a meteor? No, firefly. Yeah. So, I'm outside the dome now, and I'm going to go in the dome now, but I just was thinking that it might be, a good idea to just check the conditions, and it's a good thing I did.
Right. And just to let anybody know, Paul is using an IR cut filter tonight just to help out a little bit. He thinks it does look a little bit better with it, so there is a filter on tonight for anybody wondering.
Nice.
Just so you know.
Just so you know.
Now,
the more you know, the more you know.
He's on Jupiter right now. We're still waiting for Saturn to rise up in the sky a little bit. And then, don't worry, we will be on Saturn, and as it rises, we will get it good. Being the clouds, stay away. Oh, yeah. That reminds me. Let me check the email just to make sure Amy didn't get back to me.
She said, where were you? I had 15 minutes, and you didn't answer me.
Let's see. Okay. You know what? If if anybody would see my phone and didn't know what me and Paul did, they would really start questioning me. Like I literally have a message from Paul on my phone that says 10-inch tonight. That's literally what the text says, 10-inch tonight.
Well, that's Paul's fault for not being a little bit more descriptive.
Damn, Paul, you're a stud, buddy. All right. No, what he did, well, what that means, let me translate for anybody that doesn't know. That means he was going to use a 10-inch scope tonight instead of the 11. It was a little too windy for the 11-inch scope, so he decided to use the 10-inch scope tonight. That's why you see the CPC 10-inch scope on the screen. And
that's, he actually, calls that his sail, is that what it is?
Yeah, the wind sail.
The wind sail.
He's going to have to stake it down by now. Yeah. But he did actually. I wish I could put those pictures up on the screen. He did. Mark, what are you doing? Did you get attacked by a bear?
No, I'm sorry. I'm rotating the dome a little. I apologize.
So
I forgot.
You just got abducted.
Yeah. No. Well, I did, but that's a different story. I may have to close up, but that's okay. Anyway, go ahead. Sorry.
I forget what I was talking about now.
Totally well, someone in chat will remind you.
Yeah. By the way, if anybody has any questions in the chat, ask away, because we need some time filler before Saturn comes up a little bit. So, if you have any questions about Jupiter, have any questions about Saturn, have any questions about Marc's love life, have any questions about what? Oh. Ask away. We'll be glad. Well, he'll be glad to answer them for you.
Up to a point, apparently.
Up to a point, apparently.
So, but you know what I think is a good thing to do is to. Actually, when we were talking about Saturn here, we didn't actually get a chance to spend a whole lot of time because we haven't seen it really. And when he brings it up, then we can talk about it more. But he had it earlier, I think, right?
Mm-hmm. Yeah, he's gonna bring it up. I mean, he's just waiting for it to rise up in the sky a little bit. That's all.
Okay.
Because sometimes when it's down that low, it gets really wavy. Just because it's through so much atmosphere.
It does.
So he's just waiting for it to rise a little bit. Once he does, I'm pretty sure he'll lock on, and then we'll be good to go. And plus, you can't really help it, but you just can't help but going over to Jupiter if it's there. It's just one of those.
Hello. Yeah.
Jupiter, the protector. I mean, if it wasn't for that planet right there, I don't know if we would be here right now.
Yeah. See, Saturn is smaller, and it's actually a lot less dense. Saturn would actually float in the bathtub if you could put it in the bathtub. It's actually very light. But and that's something that's well understood. But the fact is, Jupiter has basically shunted all these heavy objects, these big, massive objects that could have killed us, has shunted them away from us, and that's something that we can't even possibly imagine. We can't imagine, because it's like, how could something that far away, actually do that? Well, it's like I said. We looked at these new moons they found. Okay, the two new moons are literally, respectively, 13 and 15 million miles away from Jupiter.
Mm.
Okay, but they're Jupiter's moons. Now
just think about that for a second.
Yeah, that's what I'm getting at. Go ahead.
15 million miles.
Yeah.
And it's a moon. Okay, when you think about our moon, what, 240,000 miles?
Yeah. 2,100 miles across, you know.
Yeah. 15 million. Million with an M. Miles.
From Jupiter.
From Jupiter.
And in orbit around Jupiter.
Yeah.
Yeah.
That is insane.
Yep. That is
you would
actually
think when you think about
wild.
15 million miles, you think, okay, well maybe 15 million miles is, the distance between Jupiter and Saturn. You know what I mean? When you think about it on a scale, you're like, that's a lot of miles. But you're thinking a moon is orbiting at 15 million miles away. That's how much, impact Jupiter has on anything getting in its general area.
Yeah, and just to give you a little perspective, Mercury is only 36 million miles away from the sun. Yep. Okay, 36 million miles, and the one of these two moons is 15 million miles away from Jupiter. So basically half that distance.
Mm-hmm. It's mind blowing.
It is, because it's showing you that in spite of the fact that gravity is what we call a weak force, it's actually a force to be reckoned with, isn't it?
Now here's a question for you. How close would Earth have to be for it to be affected, like say, for it to be pulled into an orbit orbit around Jupiter? Let's say, okay, let's take the sun out of the equation, obviously, you're going to have to. But how far do you think we would have to be in order then to start orbiting Jupiter? What do you think for the Earth's size and mass and whatnot?
Well, if the sun went away tomorrow, then all the planets in our solar system would end up going and heading toward each other, and then finally gravitate toward the largest object, most massive object, which of course is Jupiter. Mm-hmm. So one way or another, we would end up orbiting Jupiter, or being consumed by Jupiter, or being destroyed in a collision, or frozen to death. Our oceans would freeze, and the oxygen would end up...
Well, this might be a stupid question, but do you think some of those objects out in the Kuiper Belt are being held there by maybe Jupiter itself and not the sun?
You know what? Here's the thing. The objects that are in the Kuiper Belt are in orbits of their own. And did Jupiter have something to do with that? Yeah, probably could have. Jupiter does regulate things. For instance, the reason that the asteroids didn't ever form a planet, and they really didn't ever form a planet, by the way. I mean, there was some confusion where people thought, well, maybe it was a planet that was destroyed. Well, actually, in reading the research, the bottom line is that Jupiter actually mediated that formation process, and it prevented the asteroids from ever coalescing into a planet. That's why we have an asteroid belt. Mm-hmm. It's because of Jupiter, in a sense. So, if that was possible, if it was possible that Jupiter were able to be, well, you know what? You could use Universe Sandbox too. Mm-hmm. And you could turn around and take this scenario, start with our solar system, and make changes.
Take the sun out and see what happens.
Take the sun out and watch what happens.
And we do have a question from the chat real quick. I wanted, it's from Sea Pirate, but I want to let Sea Pirate know. Paul is not actually on Skype with me. It's actually Marc D'Antonio, but I'll let him answer the question just the same. He says, what is your favorite planet? And Sea Pirate's favorite is Neptune. What is yours, Marc?
Oh, my favorite by far actually is the Earth.
Our solar system.
I love the Earth, man, because I can breathe here, I can live here, and but as far as obviously I recognize the flavor of the question. The other planet that's actually by far my favorite is actually Jupiter, because there's so much detail to see, so many things that we can learn about Jupiter, and Jupiter is kind of like a mini star system. And for instance, the TRAPPIST-1 exoplanet system, the TRAPPIST-1 star, and its associated exoplanets, that system is better understood by looking at Jupiter and its moons rather than the sun and its planets. Right. And that's because that star is 8/100ths of the strength and output of our sun. It's a small, tiny, little, ultra cool red dwarf. So that is a star that acts more like a planet, like Jupiter. You know, and so and its planets are more like the moons of Jupiter rather than planets around another star. And it's a matter of scale, you know. And as you've learned with the recent findings of these other moons around Jupiter, that scale is massive.
And I will have to say for the record that I agree with Marc. Jupiter is my favorite planet. Earth is by far the prettiest planet in our solar system. You know, from further away views, I mean, just you can't beat Earth. But,
I do have a second. I do have one a second.
But Jupiter is my number one, and then Saturn is a close second to Jupiter for me.
Actually, I don't have Saturn as my second favorite. You know.
Well, then you can just get out.
My second favorite is Pluto.
It's not a planet.
Okay. My favorite planet is Jupiter, and my favorite dwarf planet is Pluto. Let me put it that way.
Do you think Pluto should be a planet?
No, I understand the distinction. Okay, Pluto is probably a captured trans-Neptunian object. That is, objects out past Neptune, you know, past the 30 AUs, astronomical units, and out into the Kuiper belt, which extends out to 50 or so astronomical units or more. And that's the that particular location in our solar system is just filled with all kinds of asteroids, potentially planet-sized objects. Like I said, there's one the size of the Earth out there lurking, we think. No, it's not Nibiru, but it's actually just a large planet in its own orbit out there, dark in the cold of space. But Pluto,
and a pretty planet, or pretty dwarf planet as well.
You know? Well, yeah, I mean, Pluto is just amazing. I actually like all the findings when the New Horizons probe went zipping by it. I thought it was very cool because when I got to see some of this imagery, I got the high-res versions and talked to people that were analyzing these photos. And I found out that, you know, early on, I found out that Pluto actually had an atmosphere. And that was astonishing to me because I said to these guys, I said, well, isn't Pluto, you know, mostly nitrogen ices on the surface? Yeah, it's mostly nitrogen ices, and there's also water ice. And that's, you know, the water ices sometimes come up through the nitrogen ice and make these little mountains. And, you know, that's what they called on that episode of What on Earth that I did where we talked about the snails on Pluto, basically. These water ice mountains look like snails.
Look what Paul is capturing Jupiter right now. Wow. I mean, wow.
Looks good.
It's some of the clearest that I've seen. You know, you have a couple of high clouds like passing, but when those clouds disappear, I mean, it is gorgeous.
Wow.
I mean, the clarity, the banding. I mean, you can easily see the banding in the north and southern tier of it.
That's just beautiful. Absolutely stunning.
If you look at Jupiter and are just not amazed, you might want to have your head examined. It's just sitting out there in space, just being the guardian of our inner rocky planets.
That's right.
Out there doing its job and doesn't even know it's doing it.
Well,
and it's orbiting 15 million mile moons.
Yeah,
they have a part to play.
Most people don't even know that it's you know, got moons that are orbiting out at 13 and 15 million miles. It's like, that's incredible. You know, it's an outstanding. And the planet's doing an outstanding job for us. And like you say, it doesn't even know. You know, it's not alive to know, but of course it doesn't even, you know, have any awareness that it's probably made us. It's wonderful admirers. It probably gave us a lot of, you know, our life that we don't.
Amazing. You know. And if anybody wants to learn more about Jupiter, we do have a Jupiter stream that we did. I believe it's from May 6th, if I'm not mistaken. It should be right around there that we did an all Jupiter stream, and that's all we talked about all night was everything Jupiter. And so if you want to learn something about that planet, go ahead and listen to that stream or put it or download it and, you know, listen in your car or whatever, because it was really, really interesting.
Is that the one that I did with you?
Yeah.
Cool.
Yep.
No, that's good stuff, man. I actually like.
Here comes
this
Saturn.
Stuff.
You'll see Saturn on screen. Well, you guys will see it right now because you're. I keep reminding that we're seeing. Oh, I'm seeing stuff 30 seconds, and I'm talking to you 30 seconds ahead of the stream. But when it comes on the stream, it's actual real time. So it's like kind of confusing sometimes.
Yeah.
Yeah, we talked about that before actually with your stream. We can't say you'll see it in 30 seconds because by the time you hear me say that, it's actually 30 seconds and you're seeing it on the screen. So.
Yeah, I mean, I had at one point I had 4-second latency, which means that it was taking only 4 seconds for the stuff that I was seeing to show up on the stream. Mm-hmm. And I thought that was pretty cool.
Now let me take a minute here just before he gets Saturn totally in view here. Let me take a minute and discuss this Nibiru thing, okay? Because people have asked, I've seen comments, on our videos and stuff about people asking, have you seen Nibiru, stuff like that. Okay, listen, if Nibiru was anywhere near us,
if there wasn't Nibiru,
yeah, you would see it. You can't mistake a lens flare for the planet Nibiru. Because you would see it with your naked eye. All right, you'd see it months in advance with your naked eye.
Well, there's one thing to keep in mind, actually, and I don't want to break your train of thought here, but
you already did. Too late.
Sorry. There's one thing to keep in mind, and that is that you can't see any planet in the daytime sky other than Venus, and that's a maybe. And that's you can't see Nibiru, and all these people that look at point their cameras at the sun, take a picture, and they see, oh, it's Nibiru. Actually, it's not. That's actually a lens flare. You're right. Okay, but the reason that they think it's Nibiru is because it's this brown or this blue thing or whatever, some color that looks to them like it's got to be there in the sky. And they say, well, I couldn't see it with my eye, but the camera saw it. But the fact is that when you consider the physics, if you ever saw a planet during the daytime, and I actually taught people how to find Venus in the daytime, and I actually spent a lot of time actually teaching people how to find Venus in the daytime. And we'd look for it. I'd find it, and I'd say, okay, it's right here. Just stare right there at the sky, and I'd point. All of a sudden, they'd see it. Oh, I see it! And then they would not take their eyes off it, because if they did, they'd lose it. So, but that was something that that shows you right then and there. When you see that, then you realize just how impossible it is that what you were seeing was maybe Nibiru in the sky, because when you see a planet in the sky, it looks like a very, very faint pinpoint of light. Very faint. Yep. And that's something that you just, you have to understand.
When people talk about a rogue planet and stuff like that, you would see the gravitational effects months, if not years ahead of time.
You would actually, yes.
For this coming into the solar system. It would start screwing stuff up big time.
Yeah, you're right.
So, anybody worried about Nibiru, it's not here. It's not coming anywhere near us. It's not on its way. It's not, just stop with the nonsense.
And it doesn't even exist in terms of it's just a name, right? But,
right. Well, Planet X, they say it's out in the Kuiper Belt. Okay, so we'll give them that. It might exist, but it's way out yonder minding its own business. And no threat to us whatsoever.
No. Not to us whatsoever.
And it's there millions of years. It'll be there millions of years more.
Yeah. In fact, billions of years. And but that's the thing about astronomy. Okay, it's that one science left that people don't really have any answers for. Generally, in the great population of the great public, right. They don't have any answers for what is going on in astronomy. So sometimes, to sound more authoritative, they'll start making the stuff up, or they'll say it authoritatively even though they're dead wrong. And that's I see that all the time. And I don't typically tell people, well, I'm actually I was a professional astronomer for years. That's what I went to get my degree in. And I don't tell people that. I just let them talk, and usually it's somebody else next to me that says, he's a professional astronomer. And then all of a sudden, everything they say is, well, I thought that, and I think that. Yep. Maybe it's, and then it becomes maybe, not it is. It's like.
I like the people that get, really defensive.
Yeah.
You know, almost like because the old adage is, if you're denying it, it's the same with flat Earth people. If you're denying it, you're part of the cover up and conspiracy. You're a government agent. You're a
Right. That's why NASA's so evil. You see.
Yeah, NASA is evil.
NASA.
You wouldn't have Velcro if it wasn't for NASA. I love Velcro.
NASA says it doesn't exist, therefore it does.
Yeah.
It's like, wait, what?
It's just anything contrary to NASA seems to be like a whole, niche in itself.
And that's that little crap storm that they always like to portray. That's amazing to me because little does anybody realize that NASA is as dysfunctional as any family.
Yeah.
That's dysfunctional. Okay. One hand doesn't know what the other is doing. They're begging for money half the time from the government. The science directorates and the missions that they're trying to do are hampered by red tape more so than any other. Do you know how hard it was to get Cassini going? They couldn't even get Cassini off the pad. You know why? They had to fight with people that thought that the Cassini could crash and spread nuclear obliteration because they had a nuclear reactor.
Well, not only that, but the infighting. It's like when they go to disperse these funds that they do get. Well, we need this funding more than this department needs it. And it's like, and you expect them to keep a secret like a moon landing hoax? Yeah, okay. It's just not going to happen. I'm sorry, but it's just not.
Yeah. I was always astonished how they thought that the moon landings were a hoax. That was just ridiculous.
Yeah, and the fact is that anybody that thinks the moon landings were a hoax, any evidence that they put forward trying to say like this is proof that the moon landings were faked can easily be debunked. Some of it takes a little bit more, explaining. Mm-hmm. But yes, it can, and that's one reason why I love Amy Title, because she went totally in on the Apollo people and gave answers. You have a graphics company that actually recreated the actual photos with actual reflective properties of the moon surface and all that stuff, and validated the photos that were taken. Of course, Marc, all the stuff that you have done with it. So it's like, they can try. And the sad part is you get people that listen to it and don't bother hearing the actual truth and the facts about it. They'll just automatically assume, like, yeah, why is that? And then never look further into it.
Yeah, that's true. And then they just, the people are out there that's trying to, these armchair specialists, these armchair, experts.
YouTube scientists. There's two types of people on YouTube. It's YouTube scientists and YouTube comedians. And YouTube comedians are the guys that come into the chat and just say, I see like brown dwarfs on your anus. Okay, yeah, we heard that 7,000 times. It wasn't funny the last 699 times we heard it. But once again, YouTube comedy, gotcha. Golden, thumbs up. And then, YouTube science is basically people that create channels and learn their conspiracy theories from other channels that have no credentials for them either. Right, exactly.
And then they sit there and claim. Yeah, they're reinforcing each other with their silly stupidity.
It's that self-reinforcement.
Yeah.
It's like, you see it all the time with the Nibiru channels, and then you see it with the Flat Earth channels, and it's like all they're doing is trying to validate each other. And then anybody that adds a little bit of hint of fact to it, they're in on it. Conspiracy, government agents, government shills. It's like, no, it's just, think about it.
Yeah. I got to tell you, when everybody knows, because I've never made any secret that I worked for the Navy. Okay. I've done a lot of work for the Navy. I've done a lot of work. I had, very high clearance for a long time. And only when I had to have the surgery where I had to have an extensive recuperation did I actually let my clearance lapse. And I don't know if I want to get it back, because I kind of enjoy not having the invasion of my privacy by government officials who can come at any moment and go through your house and check to make sure you don't have bugs in the walls and stuff like that.
Hold on, Marc. We got a lively one in the chat. Diana says that we are idiots. She says YouTube scientists are the one doing the experiments. If they were doing the experiments, they would figure out the Earth is round. You dummy.
Well, make sure you understand her Make sure you understand her meaning.
There it is. We were bought and paid for. Please, no, let her continue. Please, for the love of God, let her continue.
Oh, well, let me finish my story, because this will help reinforce her. She'll think she's a genius after I'm done.
Well, obviously she already is.
Well, listen. So I had on ATS, above top secret, somebody actually wrote a post that said about me, that I'm bought and paid for, and all this stuff. And they said, this guy has worked for all these 3-letter agencies, they're obviously referring to FBI, CIA, and all those things. All right.
Yeah.
Well, okay, I have done some of that. And then people, when I looked at the page, this guy made it sound like he had been researching me for, extensively. And I read what he was putting up there, saying he's worked for these guys and these guys and these guys. I was able to research this, he said, and I found it all out. He sounded like he's really smart, this YouTube scientist he was, YouTube detective. Well, anyway, I saw the post, and I responded, you had to click your mouse one time on my website to get that list you think is so secret. Okay, you're no genius, because I show my clients. I'm open. I'm an open book, pal. I have worked for those people, and guess what? Having a clearance has been difficult, because I ask these guys, when there's a classified project that's up there, say in the UFO realm, that's flying around in Idaho like there was. Mm-hmm. I said, I need to know what this is, and I said, and they said, well, it's this thing, but you can't tell anybody what this is. I said, no. I said, I've got to tell people. I've got to have a statement. And they said, tell them nothing. I go, no, I'm going to tell them something. And if you don't tell me what to say, I'm going to make something up, and you're not going to like it. Yeah. So, like, a couple of weeks went by, and then they finally sent me a statement from the program office in Washington, which said what it was. And it turned out it's no longer a classified project. It's called Project Cormorant, like the bird. And if you look it up, Project Cormorant is this flying device that leaves a submarine, goes to the surface, takes off, flies like a bird, does a mission of whatever kind, reconnaissance, ordnance drop, whatever, comes back, lands in the water, folds up its wings, and sets itself back, goes underwater and dives, and goes back inside the missile tube from whence it came, and the sub goes home. All right, it's a true flying sub from Lost in Space, from Voyage to the Bottom of the Sea. And I was, I then became contracted to build some very high-end engineering models of this thing. And I did, and the thing's made by Lockheed. And I demanded to get information. And they basically said, you're endangering your position on this project. You're doing this work for us by making these, stupid demands for information. I said, look, you can tell people what these things are without giving away all your little classified trinkets, okay? Just tell them what they need to know, because they're sending them in as UFO reports. And as UFO reports, it's become, it becomes really, really onerous on me. I have to try and make stuff up, and they finally did come through and with a explanation, which was great. They did this. I was happy they did this, and that means that now I didn't have to worry. But the fact is, I had to do this, and yes, I've done that kind of work.
Let me ask you a question from the chat from Paula Hampton. And I'll let you go ahead with this one. It says, question, how is it that we can see something this well that is so far away, but we cannot see the flag on the moon?
Well, we're not seeing it very well. Okay, as good as it is. If you saw Jupiter, the way we can see Jupiter with some of the probes we've sent up there, you realize just how bad it is. I mean, it looks beautiful, yes, but it's really very, very low res. It's not good at all. Now, Paul, of course, will say, hey, but he knows exactly what I'm talking about, and he agrees. Okay, we know that the view that we're seeing here is by far a very good Earth-based view. Mm-hmm. But the resolution of the cameras that are focusing on the moon, take a look at what happens when Paul takes that same camera with the same telescope, the same lens, and points it at the moon. Do you see the size of everything you're looking at? Do you have any idea how much higher resolution and higher magnification you require to see not a flag on the moon? Let's say the entire path that the rover took on the most extensive mission it ever took on the moon. You know, they left tracks, and you can see them from the the LROC browser, the Quick browser, the Quick Map. Yeah, that's a lunar reconnaissance orbiter. Mm-hmm. You can see those. You can even see the descent stage of the lunar module sitting there, and you can see the tracks. Well, guess what? How much higher magnification would Paul have to use to see it? To see that? He'd have to use so much more that it would be far beyond the capability of his instrument.
Well, not only that, it'll start to depixelate. I mean, when I was reading up on this, and actually with the setup that Paul has, I believe that just the site itself where the rover is, and like that entire area where the rover is, the flag is, the tracks, and all that stuff, is less than 1/8 of 1 pixel compared to his size, what he images. Now, yeah. Paul does great imaging, and we really get in on the craters. But imagine that 1/8 of 1 pixel is the entire size of the entire Apollo 11 landing site.
Yeah.
I mean, you just can't, you cannot image the Apollo sites with a land-based telescope. You can't do it. They can combine, they could use a bunch of huge telescopes from around the world and point them at the same spot and kind of composite them together. But any Earth-based telescope is not going to be able to resolve it. It can't happen. You would need telescope, 300 meters at least?
Yeah, it was going to be really big to actually see it.
I don't know what the exact
you can't do it. You're just not able to do it.
Yeah.
I don't actually know what Paul's magnification is that he's using.
He uses magic.
And it's magic. Okay, that doesn't... Fine, it's magic. Yeah. It's magic,
but just like, I mean, we were talking about Walson earlier. I mean, John Walson has, he does a really good job as well. He can really get in. Now, whether it's, actually live of the moon can be debated, but what he does image of the moon is really good.
Yeah, I mean, and if he's doing things that are novel and unique, then the last thing you should be doing is hiding it. You should be able to say, "Hey,
yeah,
let's do something with this."
So I mean, I love the fact that how many astronomy YouTube channels are popping up now. Whether like Astronomy live stream, you see him in the chat. Great channel, great resolution, great pictures. You have a lot of educational channels popping up with people teaching other people how to use telescopes. You got to figure before. I mean, obviously you have your guys that started this, with Bill Bryson, and as much as he's disliked by a lot of people, Dark Skywatcher, was very influential in a lot of people starting, telescoping and live streaming it and whatnot.
Yeah.
But to see where it is now and to see how many people are actually doing it, it's encouraging. And as we always have said, the more eyes in the sky, the better.
I agree with that. I agree.
Because the more chance we'll have to catch something.
Yeah, that's right. So how many people, have actually, been able to look up in the sky and see something that they can't identify, right? I mean, well, the more people that are on a stream, the more people that are out there doing this, then the more chance that you'll find something.
Right, and everybody gets excited about the little things that we find that we can't identify, but we hope to identify them, because the more we identify, when that special one comes along that we can't, that's going to be, that's going to be the what do you call it, the Graceland.
Yeah.
Because we can be like, okay, we know it's not that. We know it's not that. We can go through the checklist of everything that we've seen before. So the more stuff we identify and the more stuff that we see, and the more causes of that, all of a sudden, when we see something,
Yeah.
And, let me do some shout-outs in the chat, because there is some people around I haven't seen in a while. What's up, Daniel Soul? Daylight, Ohio. Doug, what is up, man? I haven't seen you in a long time. I know he was having some inner strife with himself about the whole flat Earth thing, but one thing I like about Doug is he will, sorry, I don't mean to use your real name. One thing I love about Daylight, Ohio is he'll actually do critical thinking. about what he's looking at and the communities that he's looking at, whether it be flat Earth and Nibiru or whether it's real science. He'll look at it objectively, from both sides of the coin and make what he believes based on that. So if you guys haven't checked out his channel, go ahead and check out Ladle Ohio's channel. I'm not sure if he has much astronomy up there, but he does have some kind of inner monologues that he does, which I find pretty fascinating. Jenny's in the chat, and Toss the Llama. Where do you guys get these names, man? I think, do we have Jay Leno's chin the other night? Yeah. Rockstar and Deidre and Carolina and Sea Pirate.
Sea Pirate, yeah. They lie.
Phi. Yeah, They Lie Ohio. That's the guy I was talking about.
Okay.
Ted Bronson and Abe and Blaze.
And
man,
Alex.
we're up to 255 people. So,
awesome.
Excuse me if I don't get to you in the thing. We are watching. I think I have a 15-second thing on the chat just so we don't miss anybody's question. Yeah, Ava and there's so many names, but yeah. So welcome to everybody. We're sitting here checking out Saturn. We have a couple passing clouds.
No, Platani. We don't believe the Earth is flat. No,
we do not believe the Earth is flat. I'm sorry. I just had to yell at somebody for that. Because once again, she was one of those obnoxious ones that just drive me insane. And tonight is not the night.
Did she get banned?
On my nerves. I guess she did. I guess one of my mods took care of it, but because that's what they do. They are the mod squad. If you come in and you're being an idiot, you go bye-bye.
Yeah.
And that's why I have the people that I do, because I know, I know that.
Well, hey, I mean, look, and Keith is very strict about this. I mean, even he actually banned me.
Yeah.
One night, when I actually, was saying, I was talking about real science, and he wanted to talk about the flat Earth, and I just wouldn't let him, and so he banned me.
Yeah. I ain't gonna put up with Marc. I don't care how big his name is. I'm booting him.
Not very big.
Yeah. But yeah. I mean, once again, if you can believe whatever you want to, that's fine. You believe in a flat Earth, believe in the Nibiru is going to kill us tomorrow. That's fine.
No, you can't believe in a flat Earth.
Just don't be an ass. Just don't be an ass about it. Don't come in and just say, "Oh, you guys are government agents because you think the Earth is round." I mean, come on. Just stop it being silly.
Hi, Deirdre. I said hi to Deirdre. She's like a whack-a-mole. So that's whack-a-troll.
Yeah. So, once again, if you believe in a flat Earth, fine. That's fine. Have at it. And you can talk about it as much as you want on your own channel. And feel free to go do it, and I will not have an opinion one way or the other about it.
Okay, but I would like to just say that if you want to talk about a flat Earth or a spherical Earth,
I don't.
You have.
No, just go ahead.
I'm glad you asked because. What you want to consider? Keith really tolerates me well. This is good. This is good for him. It's therapy for him. You see, folks. So, if you want to talk about a flat Earth, you have to understand that when you talk about all the things that they say have to happen for their scenario to be true, you actually have to believe far more outlandish, factual, quote unquote, things than you do to just believe the Earth is a sphere, because you have to figure out how gravity can be applied through a planar surface evenly, as it is. You have to try and have a way to reason about why the North Pole climates above the Arctic Circle are in constant daylight right now, and the Antarctic below the Antarctic Circle are in constant night right now. You have to try and put that together. Try to have a theory for why that should be.
Oh, but they will.
Oh, and they do. But the fact is, then you have to figure out how. And this is how outrageous it gets. For them to say that GPS satellites don't exist, but they're on these big balloons. Yeah. GPS satellites are on balloons all over this flat planet.
And radio signals are from giant towers.
And as proof, you know what they show? They show radio towers and say, "See, really?"
The best is the Nibiru people trying to use NASA's like STO and stuff like that to prove. And it's like, and then all of a sudden they're like, "Yeah, but NASA's fake," and I'm like, "You're using their science for what you're claiming." You know what I mean? You're using the STO that was developed by NASA.
Yeah, because it's convenient to use their stuff because it proves our point.
But they're hiding it from us.
But they don't exist. Remember, they're wrong. Remember.
I'm gonna have an aneurysm.
Well, not about this. Like,
oh,
that's funny.
Man, it is. I mean, just the silliness is just. Is it YouTube culture? I mean, is that what we call it? Because I have a shirt that I'm actually getting made that says flat Earth is intentional retardation. and I am coining the term intentional retardation because that's what it is. You're intentionally deciding to believe something against facts and reason. So it's like, maybe I should do that. Anybody want an intentional retardation shirt?
Actually, how about this? I got another one for you. This is a little catchier than intentional retardation. Okay, how about intentional idiot?
Yeah.
I'm an intentional idiot. That kind of thing. So and when people ask why, that you can say.
Well, the sad part is I don't think these people are idiots. I think that they've just been led astray by people that are smooth talkers that sound like they know what they're talking about.
Well, that's what I was saying before when I was still out in the dome. I'm in my office now, under my red lights. I have a programmable Wi-Fi lights in the office, so I just say, "Hey Siri, set condition red," and boom, the lights go to red.
Show off.
Hey, well, the Wi-Fi lights.
You wait.
You saw these. I told you all about them. You're getting them for your studio.
Yeah.
Don't even tell me.
You wait. I'm gonna see if I can outdo the D'Antonio.
I think you should. See, that's very healthy to try and outdo your friends, and then come back and
here's the thing. My goal for the studio is the fact that instead of Paul driving all the time, because once we get the scope up here in Pennsylvania, that Paul would be able just to fly up here, for weeks or whatever, throughout the year, and actually do the same thing, but just doing it here, in the studio here, which, it's all kinds of stuff we were talking about. And once again, I mean, we did a lot of talking up at Bill's house, but I think we have a lot more to do, and we need to get all four of us together this week sometime so we can finish off this website so everybody has a place to go. To check all this stuff out. But
because we were going to actually, Keith and I were talking earlier, and he had good reasons why it probably wouldn't be a good idea. Now, I was a computer science guy for many years after being an astronomer, so I went on to go into get my. I almost finished the master's program in computer science, and then realized I ran out of money. But the point being that this stuff is not, the science of the internet and the IP addressing schemes and how we can all get to communicate together, how YouTube works, all this stuff. That's not foreign to me. I understand all that. So when Keith and I were talking before about possibly having my stream going at the same time his stream is going tonight, he said, well, I think maybe what we want to do is wait until we get the site up and running, because that'll be better, because then we can actually have that official location where it'll be a nice jumping off point. And I agreed with that. I thought that was a good idea.
Well, that way, they don't have to open it in two different browsers and minimize their screens and stuff. That way it'll all be on the same page when it's on the website. And they can literally look at one next to the other, and if, say, all of a sudden we start talking about, because we'll be watching that page as well. So if we start talking about, stuff, we'll be able to see both of our side by side.
Yeah.
And we can say, hey, look what's going on Marc's stream right now. He has, this, blah, blah, and all of a sudden me and you start talking about what you're doing. And then say Paul goes over to something, and all of a sudden we switch over to what's going on, and then Bill has some, we can literally do that live where we're actually flipping between things just to make it more fluid. So you don't have to have three browsers open and three different chats, and I don't know.
That's right. Now I see Ronald Tolvtar in the chat. He writes, the rings are formed for moons crashing into each other. And also, they have noticed recently moons being formed within the rings. Actually, just to sort of elaborate on that, Ronald, thank you for that, offering that. I wanted to mention that the rings may never have had the chance to have been a moon, because the ring system is a ring system because it is too close to Saturn for a moon of any substantial size to form. The gravitational tidal forces on that moon, if it would be there in the ring location, would have torn it apart and ripped it to shreds. And so if at one point during Saturn's formation there were rings, I'm sorry, not rings, but moons that were spiraling closer to the planet for whatever reason through other gravitational energy trade-off, which happens a lot, okay? Some moons, you know, as they settle into their orbit, you find that the tug from outer moons beyond it will maybe slow it down enough so that it drops lower in its orbit. Finally, it reaches that critical point where it's within what's called the Roche limit and gets ripped to shreds. I mean, it's possible that could have happened, Ronald. So that is a possibility, and I won't take that a possibility off the table, actually. But as far as what's inside the rings, there have been we found these rings back when Voyager went streaming through there. You know, these rings were actually being sort of shepherded, if you would call it, like a shepherd with his flock, okay, shepherded by what they call shepherd moons. And these are tiny little moon fragments, you might say, inside the rings. And they have their own gravity, but it's very small, but just enough so that when you look at the rings and their structure, that structure is something that is synchronized, you might say, and maintained by these shepherd moons. Now, to give you an idea how absolutely out of this world, no pun intended, this can be, imagine that inside the rings there are these two moons, okay? One's in a slightly farther orbit than the other, but they pass each other because the one that's closer to the planet moves faster. So that one kind of catches up to and approaches that other moon in its orbit that's a little bit farther out. Well, as it does so, they pull toward each other and they swap positions. And that inner moon now goes to the outer orbit, and that outer moon goes to the inner orbit. They literally cross paths and swap positions. This is part of that little dance that the moons set up when they start to settle into their final orbits inside around Saturn or Jupiter even. Mm-hmm. And that's very cool. I think that's just awesome. You know, that they swap positions. Mm-hmm. So that's a crazy thing to think about, that these moons actually change their orbits when they go around Saturn.
Now, when it comes to, I know, what is the time frame it takes light to get to us from Jupiter? 8 minutes? Or 6?
Well, 8 minutes is the sun.
Okay, what's Jupiter?
Okay, distance to Jupiter. Let's see. Let me remember now. The distance to Jupiter is. Let's see. Jupiter.
Math.
Math. No, I'm just trying to remember because distance to Jupiter. How far away?
While you figure that out, I'll answer some questions in the chat.
It's 365 million miles, I think.
You figure it out. I'm going to answer some questions in the chat, okay? And then tell me what it is from Saturn, too, how long it takes light to get from Saturn. Nancy, yes, it is hooked to a computer. It is done through a computerized telescope. It does go through that way. Let's see. Let me just run back in here. Let's see. Flat Earth, blah, 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 yada, yada, yada. Boy, they are persistent, if anything. I'll tell you that.
Aren't they?
Well, Seapire says, wouldn't it be cool if we can see Jupiter's big red dot? Stay tuned. You will. You'll see it coming around shortly, and we'll see how long it takes to actually cross the face of Jupiter.
And the fact that he's calling it a big red dot goes to my point, what I was saying before. Mm. That big red dot is the size of the Earth. Okay,
and that was bigger.
Well,
at one time it was maybe.
It's been shrinking, yeah.
Yeah.
But so that big red dot is the size of the Earth, and calling it a big red dot means that you're not seeing all the detail inside. It just looks like a red, amorphous, featureless thing, other than being red. And you know, telescopes that have the capability of seeing that in any more detail have to be in space. Right. They can't be underneath the veil of this atmosphere. So.
I should actually have Stellarium up so I can tell you what moons are which that you're seeing. They're floating off the side of. Once again, you're seeing Jupiter overexposed, so you can see the moons. You got two to the left-hand side there and one to the right-hand side. And actually, let me open that up just so we can give people what they're looking at.
Yeah. I actually had...
And I should say, Paul, this guy... This is the kind of guy Paul is, okay? Let me explain this to people in the chat. we were talking up in New York, and my laptop just wasn't very powerful enough to sustain the thing. This guy sent me an Alienware laptop. As you know, they are not cheap.
No, but remember, he stole it.
That's
a joke.
He sent it up to me, and literally, I'm actually able now to use a secondary computer so I can run all the, the ones that take a lot of CPU, like Stellarium and Skype and all that stuff while we're streaming, and actually be able to process everything. But this guy sent me an expensive computer just to be able to do this. And I mean, you guys, there are videos on here when we were up in New York of Paul, and I think he's going to get really comfortable doing it on the mic and stuff like that. So we plan on having him more, especially when we get the site up. On nights that we're not able to stream, I'm actually going to get him to jump on with me on Marc or Bill's channel, so he can hang out there and you guys can ask him questions and whatnot. Because I realize we really haven't had a good Q&A with Paul. We were kind of just thrown into it up in New York, but he seemed to really get used to it. Really liked being on the mic and answering people's questions, instead of having to do it third person through this. And the only reason we do it the way we do it now is because of the bandwidth issue that he has down where he is. He can't maintain the stream and be able to run Skype as well. And that's nothing to do with his computer system or anything like that. It's more to do with the bandwidth his upload bandwidth is absolutely silly. I think it's like 1 megabyte per second or something like that, and that's all being used by the stream. So, but we're able to keep in contact via chat on Skype, and that's how we've been doing it. And it's actually been working out pretty good,
Wow. Well, while you were just talking, I calculated how long it takes light to get here from Jupiter.
All right, inform me.
Well, first of all, Jupiter's 365 million miles away on average.
Mm-hmm.
Okay. Now, light travels 186,000 miles per second. So, if you take 365 million miles and divide it by 186,000 miles per second, the miles cancel and you get seconds. And that answer brings you to 1,962 seconds, and that's 32.7 minutes. So it takes 33 minutes, basically, for light to get here from Jupiter.
Well, there you go.
So, yeah.
How about Saturn?
Well, Saturn is going to be the same type of calculation. We just have to...
well, that's what you were supposed to be doing, Marc.
Oh, how about that? Well,
That's all right. I forgive you.
Yeah, well, I hope so, because, I won't teach you the math.
Yeah. That's okay. I don't think my brain could handle the math. I think you're some kind of robot, or maybe the government put some kind of chip in you, or I still haven't figured you out yet. But I'm gonna figure you out, and when I do, I'm gonna expose the crap out of you. Are you an alien?
Oh,
go ahead. You can tell me now.
Yes, I am. I'm sorry. Don't tell anybody.
Are you from Andromeda?
No, are you kidding me? Don't you know everybody's from Zeta Reticuli?
All right, there's a beautiful Jupiter. Once again, let me tell you what the moons were. It's not overexposed right now, but when it goes back to overexposure, you will be able to see it. You are looking at... let me expand it a little bit here. Stellarium really needs to work on the ratios, so I don't have to F11 out of the program all the time. All right. So to the left of Jupiter, you see the two moons that are kind of one on top of the other. You're looking at Ganymede and Io, and the one that's off to the right is Europa, and I believe Callisto is on the backside right now. And if I'm not mistaken, which I might be, so don't quote me on it, I believe I see the storm starting to come around.
On the left side?
Yep. It could be. It might not be.
Might just be a shadow, but you might be right.
Could
we
be.
have to see.
Yep.
We'll have to see.
All right. Let me see. And I'm sorry. I'm trying to keep up with the chat there. I'm sorry if I'm missing any questions. Once again, hello to everybody. 347 people watching. Welcome everybody. I've been posting Marc's channel link in the chat for anybody that wants to go over there and subscribe. Once again, Deep Sky Objects, great. If you want education on astronomy, that is the channel to go to. I mean, I'm still learning stuff every day. Every day he streams, I'm learning something new, and that's
That's
a feat because I hate learning.
Oh, come on now. It's wonderful.
No, I mean, I'm serious. I mean, how many people in the chat, when you were in school, you could not wait to leave and be done with it. But say you get into your 20s or your late 20s, and all of a sudden you're like, you start piquing interest that you really didn't know you had before, and now you're like me, I'm cramming it all in now. Like in the last 10 years, I've been cramming self-education into myself just because I was such a slacker back then.
But see, you know what? I want to just pass on to everybody here. The other night, Keith came on to the Sky Tour live stream, and we were doing a stream. He joined me on the stream, and we were looking at some deep sky objects, globular clusters and so forth, and double stars. And every object we came up to, Keith had some valid factual data to add about the object. So
yeah, but what I'm saying is I've learned that in the last like 10 years, and I'm learning. As I said, I was doing orbital velocities of planets compared to Earth the other day. You know what I mean? It's like I would never give a crap about that 15 years ago. Anybody that doesn't know, I mean, I'm 37 years old. It's like in the last 10 years, I've just been constantly. It's almost like when you get a certain age, you almost become a fiend for knowledge and information. I mean, is anybody else like that? Like anybody in the chat? Or
yeah,
maybe I'm just
No, I understand that feeling. I'm definitely definitely. Me too.
What a dick. So tell me, Mark.
Yes, sir.
As the only reason, I should tell the people in the chat as well. The only reason we're staying on Jupiter for a little bit right now is just because we're about to lose it. So that's why we're just getting our last views of it before it sets, and then we'll be straight up Saturn the rest of the night. And hopefully, as it gets higher, it'll get clearer, and we can really image it pretty good. So
yeah, I think it will. I think it'll be good. Because Saturn was...
Mark, the chat is having a field day with your coughing and clearing the throat.
Oh, God. Yeah, well...
The man talks, man. That's what he does for a living, the poor fella.
Yeah, sorry about that. I actually do have a cough button here. I should be using it.
That's all right, man. Dude, as much talking as you do and as many people as you educate on a daily, I'm pretty sure we can excuse some coughs and clearing of the throat. Because I do not blame you one bit for knowing as much as you do every day. And I want to personally thank you for coming on this stream and educating a lot of people as well. Because I know you take time out of your schedule to do stuff. I mean, you could be streaming on your own channel right now, and you came on here, and you're giving it a go like a champion.
Oh, thanks, man. I appreciate it. But, just to... not to make excuses or anything, but I actually, I do have one of my vocal cords is actually paralyzed. My right hand paralyzed. I have only one cord. The right one is paralyzed now. So I just have one.
Was that for the accident or?
Well, no, actually, 2 years ago I had an infection in my heart valves, and they had to replace 2 heart valves like an emergency. And I almost died. And when I finally woke up, I was in a coma. When I finally woke up out of the coma, I was blind and I was a quadriplegic because I had 6 strokes during the surgery because the clots got away from them in the heart because of the infection, and they just blasted my brain like a shotgun. So when that happened, I was unable to move. Nothing. I couldn't move anything. And my left foot is still paralyzed. Not paralyzed, but numb. And I ended up with this right vocal cord being paralyzed, for good. And I have a little bit of occlusions in my eyes, right? I can still drive, which is great. I only kill 3 people a day, not 7 like it used to be. So that's pretty good, right? I mean,
yeah.
So that whole thing to me was like, I'm very happy to be here. So if someone wants to, someone has a problem with me coughing, I say thank you, because at least I'm here to cough. I'm not upset with anyone for saying that. I'm totally understand, and you're right. It's freaking annoying. So I have to be careful about that.
Knowing Mark, I mean, I've probably known you for what now, about a year or so. Known you real well for probably about 6 months. What I like about Mark and why I have him on so much is because he can simplify a lot of stuff to everyday terms, which not a lot of people can do, which is why I like listening to him, and is why I learn so much from him, is because he takes the, I don't want to say dumb it down, but he brings it down and words it in ways that everybody can understand. And I seen this firsthand when we were up at Pine Bush. You know, there was just people walking around everywhere, and as soon as Marc started talking at that tent, next thing you know, there's hundreds of people. Like, he has that power for people just to stop and listen to him about what he's talking about, because he knows how to hook you right off the bat. And that's basically the sign of a good educator. And to me, I personally believe that I cannot believe you're not teaching in a college somewhere.
I did. You know, I tried that, and I've done it, but
just wasn't for you, or
no. You know why? I wanted a bigger audience. I wanted more people at a time.
Yeah.
You know, I used to travel. You know, as a professional astronomer, I was working in observatories doing parallax studies and near star studies. And when I left there and moved on, I wanted to go into teaching astronomy and then beyond. My goal is still, I want to actually get a master's in planetary science. So I'm actually going to head down that path when I get to Arizona. I'm actually going to go to maybe an ASU, you know, and do that. But besides that, okay, this when I started going out and teaching astronomy, I was actually a traveling itinerant, you know, teacher. Mm-hmm. I taught everything from college to kindergarten, for crying out loud, and I did it for 3 or 4 years. And then that burned me out after having 2 accidents where I fell asleep at the wheel.
Marc taught kindergarten, and now you know that class, that entire class is now known as a company called SpaceX.
That's so funny, because what that says is you think I'm that old. Anyway.
Marc, in reality, how old are you?
I'm
Just so everybody knows. 56?
I'm 56, yeah.
So, I mean, you're still a pup yet. You know, you've been through the ringer a couple times, but you still got plenty of chain left in the yard, if you know what I mean. So, I mean,
I do.
But the fact that you, I like the fact that you have an affinity for what I'm going to term mass education. Like, YouTube is a perfect thing for that for you, because, you know, as I said, like tonight, our normal watching nights, you know, we get, 200 people watching at a time. I mean, look at it, right now it's 387. I mean, yeah, you got people that are just stopping and checking in and whatnot, and see what it's all about. But, a lot of people are hanging around. I mean, the numbers are usually hovering. So, it's like, and I'm sure a lot of our normal people in here will agree with me when they said that they have probably learned more from you since we have been doing this than they did their entire schooling. Either because, A, they weren't into it back then, or B, they didn't relate to the teacher that was teaching it, and they just, and I can literally sit here and say that right now. I have learned more from you than I did in my entire schooling.
Wow. I mean, that's well, of course, because you didn't go to school for astronomy, right?
Exactly, but you've got to you have science classes pretty much from intermediate up. You're talking, you start taking, basic science in what, second, third grade. You start learning about the planets and all that stuff. So, but then once you get into high school, you start getting into, because I'm not into math. I'll never be into math. You will never hear me, sit here like you just did and say, all right, let me figure out the calculation of this or that. Why? Because there is people like you. I can go, hey, Marc, figure this out for me.
Oh, and I forgot to tell you, 66 minutes, the light, it's just over 1 hour, 6 minutes.
I know you were going to do that.
Light hour from Saturn.
Right. But,
so you're seeing Jupiter 33 minutes ago, you're seeing Saturn just over an hour ago.
Yeah, so it's like, I know a lot of people would agree with me in the chat, and once again, I cannot recommend Marc's channel enough. I'll post a link again in there for anybody who wants to subscribe. He may, depending on what the weather looks like, may stream after this. I don't know how it's looking up there, but
I actually closed up the observatory because a large cloud bank is rolling through. I don't know what it'll look like in an hour, but that'll be 12:30 by then. So who knows?
Well, either way, you try to do it as much as you can throughout the week.
I do.
So
I always do.
And then once in a while, I'll jump on there with him. He does have Amanda over there with him sometimes, and I'm sure as we get this all formulated and get it done, you're going to see a lot more crossing over. And the whole point. I mean, I hate to say it, Marc. I hate to put this pressure on you, but you are the backbone of this operation because you are the educator.
I I think that Paul's doing a great job. I think Bill does a great job, and I think you would probably see more of Paul if you had him in on the stream, and he was actually in with you.
Yep. Then
you would actually hear what he knows too, because he certainly knows an awful lot about astronomy.
Oh yeah, absolutely, and that's what's going to be great about one night when we just go ahead and jump on with you.
Yes.
And then he'll give you a chance to go around and maybe he'll start explaining stuff to the people, about what they're looking at and how you're doing things, and give you a little bit of a break and actually able to play like a kid with a toy. You know what I mean?
Oh yeah, yeah. No, that's good. And see, the thing is, I'm used to doing 5 things at once for a variety of reasons. I gotta, in my business, I do visual effects and now because I started a business that caters to the visual effects industry,
right.
And special effects. So I've learned to do 5 things at once, especially when you're on a movie set or whatever. You've got to do several things at once. I did a Burger King commercial a couple of years ago where I went in to build these Oreo cookies. There were 3-inch Oreo cookies, and we were going to be shooting them at each other and shooting them at high speed, so it would actually look like they crash apart and break apart. So I had to make them out of a special material, blah blah blah, and all that. But the bottom line was, I did that, and then noticed that they needed a 10-inch diameter Oreo cookie for another shot. They needed a special rig to make this brownie. It was a food commercial part, and have this chocolate running through it. So, in other words, by the time I was done on that job, I went from having one little job to having 12 jobs.
Yeah.
And I was like, every time I grabbed another one, and the guy said, "All right, it's yours," I kept saying, "Why did I just do this to myself?" I was like, why can't I shut up?
Let me real quick, just while it's on screen with the overexposure. If you look to the left of Jupiter, which is overexposed right now, the top left is Ganymede. Below Ganymede is Io. And let me just see if the right is showing. And off to the right was Europa. So that's how you're looking with the moons of Jupiter right now. Now, once again, this will be the last couple minutes for Jupiter because it is getting low in the sky, and then we're going to migrate over to Saturn and pretty much stay there for the rest of the stream. The moon comes back this week. We just had, I believe the new moon was yesterday, if I'm not mistaken, I believe. So we will be back to do that and whatnot starting this week, and I know our fingers are crossed. We had an awesome February where almost like every time we went to stream it was clear, it was beautiful, and it looks like that same type of weather pattern is setting up. So hopefully we will have a good end of June, early July.
I hope so.
That
while we're talking about the moons, it might be a good time to say, when we talk about these Galilean moons, Io, Europa, Ganymede, and Callisto, when we talk about these, one of the things to understand is that Europa is that moon that we think is, has a 60-mile deep ocean underneath its icy crust, right? Mm-hmm. But it's not the only one, because it's possible that Callisto has it as well as Ganymede. So we might find that subsurface oceans are a thing. For instance, at Saturn, Titan, frigid, cold Titan, may have enough heat in its interior, near the core, to actually support a liquid ocean there as well, underneath its icy mantle of rock and ice there. So I think that's something important to understand, is that these subsurface oceans might be a thing, in solar systems, and that water is very, very plentiful in the universe, and that's obviously something that we need to survive. Obviously, something that helps foster life.
And I cannot, is it just me, or has the national notion lately been microbial life? They keep talking about microbial life, and it seems like they do this every time, of course, that they mention water. They do it with Mars, they do it with Europa, they do it, obviously, because where there's water, there is a chance for life, as we know it.
That's right.
But
yeah, and that's true. But go ahead, finish your point.
Well, I was going to say, looking over the I can't believe I'm saying this. Looking over the YouTube UFO news, quote unquote, a lot of people believe that this is just taking baby steps and drip feeding to a possible disclosure or a ease into a very real possibility of alien life. What are your thoughts? You think they're ramping up, or they're embedding more and more of the microbial thing lately, or do you think it's just based on the discoveries that they are making through their experiments, that it's just a coincidence that they're finding more water, so they're talking more about microbial life?
Well, keep in mind, science is extremely conservative, and when you talk science with me, you find someone who is not terribly conservative about it. I'm willing to speculate on facts we don't know yet, but I speculate on what we may know or could find out. Now, there's other people out there that do that, and they actually take it a step further and say, I think this is a ramping up disclosure. I really don't think so. I think that they're just saying what they find and what they've found so far, but they're hopeful. See, just keep in mind, they're saying now, we think we can find microbial life. Just take that sentence as face value. We think we can find microbial life. Now, 20, 30 years ago, what would you have said? Would you have said, we think we might find microbial life? No. You would say, there's no evidence for life elsewhere except Earth.
I would have said, what time Sesame Street on, because I was 7.
Okay, there's that. Okay. Wait, are you one of those YouTube comedians you were talking about before?
Hey, simmer down now.
Oh, that was funny.
All right.
Ooh, he's hot.
I'll give you that
one. No, listen. But the point is, 25 years ago, we would never have said that and still kept tenure at a university, okay? Because it would have been irresponsible. Now, we're saying, matter-of-factly, we think we're going to find microbial life. We think there's a chance. 20 years from now, we might say, we think in addition to the microbial life, we may find smaller invertebrate organisms, something else. And then 50 years from now, or 100 years from now, we might say, well, I think we may find some vertebrates on this particular planet. What do you think, Bill? I do too. I think we might find some. That's Bill Nye. He's going to live 300 years, I'm sure. Mm-hmm. And so it's going to ramp up that way. Science is very conservative. They're saying, well, we think we might find this, and to tell you why, we look at Enceladus and we see that it has hydrothermal vents under its south pole. Well, the Earth has hydrothermal vents, and it's host to all kinds of organisms. Many of them are way more than microbial. There's tube worms, there's giant clams, there's incredible shrimp. There's all kinds of life forms there, along with the bacteria that they feed on. Well, at the very least, you see, we think, well, maybe these hydrothermal vents under Enceladus at Saturn, which is right there in the picture, okay? Right there, here in our solar system, around the corner, just down the block, there might be microbial life. There might be life there. Mm-hmm. That is, it's a history maker. It changes everything. Because forevermore, the people that say Earth is unique, there's no other life elsewhere, are now going to be kicked to the curb.
Right.
Rather unceremoniously, too, because they're going to see and be told, nope, you're wrong, and this is why. Okay? And then if we find larger life forms, like let's just speculate a little bit more, if I may. Saturn's cloud tops. We're used to life like us, and we think, well, you have to have a surface to live. And that's maybe true. But what if a life form could have somehow started out microbial, and because of the velocities of the clouds, perhaps stayed in the cloud tops of Saturn and managed to eke out an existence there? Maybe we'll find microbial life in the clouds of Saturn, in the cloud tops. There's also a similar theory for Venus as well. And in Saturn's case, if that was the case, if that was true, then what would that life form look like? And how would it have evolved? We can't even speculate as to how, because, again, and you and I have said this before, we have one template, our own. Everything else is speculation. But we're going to be forced to use other ideas, other thoughts, and look and speculate about other possibilities
Right.
Because the universe isn't going to let us sit still.
Well, I like Maximus's comment in the chat, and he's pretty much saying, why are they always looking for life as we know it? Why shouldn't they be looking for life as we don't know it? Or is it just because they don't know the parameters to know what to look for?
The latter thing you said is true. We only, I said it, we only have one template. We have us. Now, I also want to say this, and I might have said this before on your stream. When we look at how life forms here on Earth and how it formed, notice what we see. We are an intelligent species, but we share the planet with billions of other life forms. Not humans. I mean, I'm talking insects, other vertebrates, other creatures of all kinds. And every one of those creatures that has, say, a spinal cord or it has a vertebral structure, a bone structure, a skeletal structure, they have symmetry. I've talked about this.
I just told Paul that he was doing awesome work, and he writes me back. He says, "Please, no compliments until it's over. He don't want to jinx it."
Yeah, exactly. It's funny.
Yeah, we say that every time. Like I compliment him, he's like, "Don't do that. Don't do that. We're gonna lose it." Oh, that's funny. But yeah, I mean, I get what you're saying. I mean, imagine we're carbon-based life forms, okay?
Yes, and the universe sets up for that. Now, that's what I was saying about the symmetry.
Imagine, weren't they looking like, or maybe did they find or something like a sulfur-based life form or something like that, or I remember reading something about or how it's possible.
Well,
once again, I'm starting to get delirious, but
it's funny. you can be delirious all you want.
I'm going for my third win now. I'm going for
okay. All right. Well, I'm still on my first, and my second win usually shows up around 12:15, 12:30.
Actually, let me address something thing in the chat. The Hoary Sheet Show, which I'm guessing is a nice way to say the holy what show, says these images look nothing like NASA's. Doesn't this look like it's almost waving underwater? And that is absolutely correct. And what's causing that is something called atmospheric distortion. All right. And it's basically your light is being diffracted in all different directions, tenths of seconds, and it's also the same kind of effect that what makes stars appear to twinkle. You have, and just so yeah, it does look like it's underwater, especially when we do the moon. And I believe if the sky's like this when we go to do the moon, it is going to look magnificent.
Stunning.
Yes.
Yeah.
Until we can afford the nice adaptive optics. That we hope to get someday for this channel, which will be absolutely awesome.
It's only $12,000.
Yeah, only $12,000. Well, the one we saw that we wanted was $23. But that one, pretty much corrected for, I think it was a 3 or 4 laser.
Yeah, but you have to have independent.
I know.
You got to have a telescope to go with it.
I know.
And the telescope is the big deal.
So, are you saying you're going to give me a loan or?
No, speaking of English.
You know what I need to do? I need to start an FX model here in Pennsylvania.
There you go.
There you go. We'll add on a little section to the studio, and I'll start making models for you.
There you go. I already got another site out in Colorado. I opened up a place out there in Arvada, Colorado. And that shop specializes in making planets. We actually make Saturn, just like you see here.
Feeding Frenzy just asked if this is the clearest it's going to get. No, the Saturn is just rising in the sky. It's going to get clearer and clearer as it rises. Go ahead, sorry. Continue.
That's okay. Yeah, when Saturn transits, that is, it's at the highest spot in the sky. It'll be just stunning. And you can already see the Cassini's division, and you can see the cloud bands in the northern hemisphere, and you can see the whiter cloud bands near the central equatorial band, and so it looks just gorgeous. I'm very happy with this. This looks beautiful. And see now, if Paul takes some video of this, okay? So you say he does 2 minutes of video.
Oh, he knows. He's done it with the stacking and everything. Yeah, he knows.
He's done it.
Yep.
Yeah.
He does it all the time.
Yeah. Well, then I haven't seen any of his results. I'd like to see.
I don't think he posts them anywhere. That's what I'm saying. I mean,
jeez, what's he doing? Come on, he's got to post his stuff.
He will. I mean, Paul. He knows how to. I mean, that's how he initially got into this. I believe he was doing that and stacking images, and but then that's when he got into researching cameras. and he got hooked up with this guy in Canada that is a custom camera maker, which is what he uses now. And as you know, when we were up in New York, he ordered 2 of them, and they're not cheap. I mean, they are not cheap cameras at all. You're talking, $1,200-$1,300 a piece just for the camera.
Wow.
But they allow him to do, what you see on screen, when you go into, craters with amazing clarity,
Yeah.
So, I mean,
Stormtrooper. Let me just say, Stormtrooper is asking what's the best place to go stargazing, and he really wants to see the Milky Way. Okay, if you go online and you search for dark sky map, that will give you a map of the United States. You go to the site. It'll give you a map of the United States to show you where the dark sky sites are in this country. Believe it or not, the Northeast is pretty bad. I have a little hole here. That's where I am. And then it gets really good when you move westward. And there's huge swaths of absolutely dark, can't see your hand in front of your face areas.
There's including a couple places in the Dakotas as well, correct?
Yeah, of course. And what you do is you go to you just look up the dark sky map. And actually, if you like Google Earth, there is an overlay you can get for Google Earth that you can just bring in, and it overlays the dark sky map onto the Google Maps.
Is it just a plugin that you can get for Google Earth?
Yeah, it's an overlay that you can download. Yeah. Now, it needs a little management if you get it that. And they have an online one, too, that you can use, which is great. But if you don't have an online one, then you can just, you can actually download, the thing and put it in your Google Earth. But when you look at this thing, you can actually see where, for instance, the lights of Phoenix start to taper off. And then just about 2 hours northwest of Phoenix, which is where I want to go, is a zone where there isn't even the slightest registration of light pollution on the meters that they use to check. So it's just absolutely dark there. And you know what? I've gone all my life without seeing a nightly horizon Milky Way that was so bright you could see your shadow from it. And I'm going to fix that. I'm going to change that. And I'm going to bring my telescope with observatory down there, and I'm going to continue doing these streams from there using this night sky. And when we do the panoramic views of the Milky Way, we're going to see the freaking panoramic views of the Milky Way. It's going to be real. And the observatory, the whole idea is that the observatory is going to be automated. So
let me interrupt you one time because Damien keeps asking for Jupiter. Jupiter is past the prime. It's actually down a little far in the sky. We won't be able to get back to it. I mean, he might go back to it for a minute or so, but it's not going to look anything like it did earlier. And the good thing about YouTube is, of course, you can go back up to 4 hours in the stream and see it. So if you want to, you can just go back in the stream right there on the player and check out Jupiter earlier, and then just hit the live button if you want to come back live to where we are now. So yeah, Jupiter's pretty much finished for the night. We're pretty much concentrating on Saturn for the rest of the night. So,
yeah, I think so. That's cool. But hey, it'll be back.
So let's talk about Saturn's moons. So I know when we first brought this up a couple months back, when we started talking about Saturn's going to be up in the night sky, you got really excited about talking about the moons. And why was that? You let the people in on your thinking.
Well, okay. The bottom line, first of all, let's look at Saturn's largest moon, which is Titan. Okay, now Titan is interesting because it has a nitrogen atmosphere, and Titan is, like I said, it's very large. Okay, it's let's see, as far as the diameter of Titan, let me just go back and get to, let me see, the diameter of Titan it's actually 3,193 miles. Now, compare that to Mercury. Mercury is only 3,024 miles. Titan is bigger than Mercury, okay? So, that said, let's go back now and look at the differences between Titan and the Earth. Now, Titan, we could not survive there right at this point because Titan is too cold. The water ice on Titan is locked up. It's hard as granite in the crust. All right. Mm-hmm. And on the Earth, we have a atmosphere, which goes up, 50, to 70 kilometers. And there's nitrogen, oxygen, and some argon in our atmosphere. And we also have O3, ozone, which helps us, and protects us. And then we have the water. We have this lithosphere. We have water that's actually very it's liquid here. We can support that because we're in the habitable zone of our star, and that means that water can exist as a liquid and isn't steamed away from too high a temperature and isn't frozen. So that's a good thing. And for us, life as we know it. I always have to preface that. Mm-hmm. Life as we know it. We have to have liquid water. So. But on Titan, Titan has nitrogen in its atmosphere, but then it has methane with some argon potentially. And there's a thin haze layer, okay, on Titan that's like 300 kilometers up. All right, so Titan's atmosphere is very, very, very thick. All right, it's a very thick atmosphere, and so above that, there's nitrogen, methane. Way up high at 500 kilometers, and it sort of tops out at around 600 kilometers or so is where the top of the Titan atmosphere kind of trails off to space. But coming down to about 300 kilometers, there's a haze layer there, and we don't really get to see through that haze layer, and it always looks really obscure to us. Now, when we had the Cassini probe circling Titan 1,000,001 times, it was great. They actually were able to penetrate the haze layer with different instrumentation. And they could see that Titan had lakes, actual lakes, but they weren't water lakes now. Okay, it was too cold. What were they? They were methane and ethane. See, ethane is C2H6, and methane is CH3. So it's a very different. Chemical structure, and this structure, the methane versus ethane, is something that's systemic to Titan. We have these ethane lakes where the liquid ethane is literally supported by the absolute cold and pressure that you see there, and down below around 200 kilometers up, you have this thick photochemical haze, so to speak. That's the layer that's actually obscuring the surface from us. Okay, mm-hmm. So whereas the atmosphere can go all the way to 500 or 600 kilometers, the real haze layer that blocks our view is down around 200. And there's a thinner haze layer above that we talked about already. Now, there might be also, because of the way the clouds are, it might be raining liquid methane or ethane on Titan, which is just amazing. And then down near the surface, of course, it's methane is down near the surface. It's a true alien world, yet it's very familiar to us. And the reason it's very familiar to us is because we think that, cold as it is, this moon that's the size of a small planet is actually a good facsimile of what we looked like at one point, minus the freezing cold. So this is a good place for us to look to see what we might have looked like back in the formative days of the Earth. So so that's just Titan, okay? And we can go to, there's Tethys and Rhea and Phoebe and Mimas, right, which has this big giant crater on it, like one massive crater, and of course a bunch of little craters, and Iapetus, and of course we have Enceladus and Dione. Now Enceladus and Dione have an interesting history together, because Enceladus circles Saturn, and Dione is farther out. And what happens is, as Dione goes around, early in the history of the solar system, when these moons were forming and they were establishing their orbits, Enceladus was being slightly pulled by Dione. So what may have been a circular orbit became more elliptical, just by a little. And that pulling became a elliptical orbit for Enceladus. And just like when you push a kid on a swing, right at that right point where when you push, it continues to send the kid higher in the swing, higher in the swing, higher in the swing, that that resonant moment where you hit the kid, you push him, and he goes up higher. You feel it. You know when you've got it right. Well, that's what happens between Dione and Enceladus. As Enceladus comes around, Dione tugs on it just at that right moment.
What is the moon count for Saturn?
The moon count for Saturn?
Yeah.
I think it's 62, I believe.
Okay. Yeah, somebody said the Earth has one moon, but Saturn has 3. No, Saturn has 62 moons.
Yeah.
And Jupiter, once again, now has 79.
69.
69, I'm sorry.
Yeah.
Right.
Yeah. That's right. So Enceladus then has a slightly elliptical orbit, and the reason that that's important to us, and the reason that has been such a thing, is because that slight ellipse that Enceladus travels in allows it to be tugged on stronger by Saturn at a certain point in its orbit, and then weaker. What that does is that kind of flexes the moon a little bit. It makes it go a little bit oblate, and then a little bit back, and then a little bit oblate, and a little bit back. Now, after a billion cycles, you got to understand, that's heating the interior, because rock doesn't like to be bent, okay, in the interior, and ices don't want to be pulled apart, all right, because when you do that kneading, it's like kneading dough. When you knead dough, you notice how dough is actually kind of hard, but then after a while when you knead it, it gets all soft and pliable, right? That's what's happening inside of Enceladus. And so the ices melt and form water, and that's most likely where this ocean underneath came from. And as a result, now Enceladus is only 300 miles across. It's small, but because of that kneading, that constant kneading by Saturn's gravitational pull and Dione helping in a resonant manner to keep Enceladus going in that ellipse, that has actually caused this ocean under the southern hemisphere at the very least. But it's also caused heating on the interior, and that heating on the interior, in addition to maybe latent heat left over from formation, like Earth has, is also causing these hydrothermal vents, that is, hotspots on the quote-unquote ocean floor of Enceladus, which are spewing, as it turns out, hydrogen and carbon dioxide. Now, when Cassini was flying through a geyser stream at one point, or getting close enough to sample, it detected hydrogen and it detected carbon dioxide. That's important. And the reason that's important, okay, is because we not only saw that there were these hydrothermal vents, but we also saw that the chemicals that could make up methane were there. And we know that on our ocean floor, we had the same thing going on. And we saw that our ocean vents were spewing methane, and these methane smokers were actually, also spewing bacteria.
Without going into too much detail, just as a kind of a pass by comment, what exactly is it about the thermal vents that allows for microbial life to form?
What happens is it actually becomes a sympathetic a symbiosis, I should say, of creatures that love to eat the chemicals that are being leached off and sent up through these black smokers as on our ocean floor. Mm-hmm. Okay, this stuff, the stuff that's really interesting about these black smokers is that.
Hold on, let me interrupt you real quick, Marc. The reason why the screen is black right now, and I hate to interrupt you, Paul just messaged me and said he accidentally unplugged the scope. So it'll be a second or so. He'll be back on. No biggie. Just let everybody know he'll be back on shortly.
Oh, that's funny.
Okay, sorry, go ahead.
No, that's all right. The bottom line is, we have hydrogen sulfide being, spewed out of these chimneys, okay, on the ocean floor. The hydrogen sulfide is actually a food source for certain bacteria that are sulfide-eating bacteria. And these bacteria, okay, can and do, they will create methane as well as waste products. So if we find methane, that's actually a pretty good indicator that something's going on down there that merits looking at. Now, methane comes from volcanic activity as well. So It doesn't necessarily have to come from, creatures. All right. Mm-hmm. Now we saw we saw a methane bloom on Mars. I think it was 2012 during the Martian summer. Now, when you see a bloom of methane on a planet that has essentially no volcanism, no active volcanoes that you know of, then that's sort of a bell ringer. You say, wait a minute, if that's happening on Mars, could that be that there's actually some kind of microbial life on Mars? Because we know that bacteria poop is methane. Okay, yep. And that's interesting, because that means that now we have another thing to search for. So my feeling is that we're going to find microbial life first, and it's probably going to be almost everywhere we look that has the capability to support it. Mm-hmm. Even the places that we think are absolutely hostile to us.
And I'll tell you what I want to do now is I want to address one person in the chat, because Mark, I think we have a chance to save somebody. Okay. We have, and I'm talking directly to Cindy Howison. I believe I'm saying it right. Okay. Now, she's admitted that she is a flat earther. Okay. And I would like to invite her to go ahead and volunteer information of any truths that you think about flat Earth, and I'm pretty sure that Mark can answer why that proof is wrong, if you would like to. It's totally up to you. But I've been watching you closely throughout the night, and I'm seeing that you might be on the fence about some stuff. So I just want to put it out there. So any of the mods that see Cindy House in there, if she wants to ask the question about something that she may understand about flat Earth and want an answer to a why it's not right, feel free to let her ask the question, and we'll see if we can't get Mark to answer for you and give you an answer, a factual answer. To any of the questions that you have, if you are in fact on the fence about the whole flat Earth thing, because she's been respectable all night. She's not been one of those jerks that just come on and flat Earth this, flat Earth that. She's been listening along. I've seen her commenting on stuff. So I think we at least owe her that.
She just asked, can you prove that we are not surrounded by Antarctica? And I would have to say, how do you even remotely prove you are? I don't know how you can actually prove that we are surrounded by Antarctica. Because if you go in one direction on the planet, if you fly in an aircraft, if the Earth was flat, you would eventually hit Antarctica. But if you fly east to west, you just keep flying over Earth and you go all the way around the world. And don't forget, we did have a balloon that traveled all the way around the world and was tracked every step of the way. In fact, I met the people who did it. I was actually with them, not in the sky, but I actually got a chance to sit with them. Remember Jeannie Yeager and Burt Rutan? They flew around the world in the balloon just to prove they could do it. That was many years ago. Well, anyway, the bottom line is, when we fly east to west, if we were surrounded by Antarctica, then at a certain point, flying along the same lines of latitude on the Earth, latitude goes horizontally on the Earth, and of course longitude is north-south. Okay, if you fly along the same lines of latitude, you come back to the place you started from, eventually, 25,000 miles later. Now, if we had Antarctica, we would see that long before we got back to where we started. In fact, we'd never get back to where we started. We would go to an edge, right? So that's right off the bat. That's something that the flat earthers have never, ever, ever been able to explain to my satisfaction in any way, shape, or form, is how they make it so that their ships never see Antarctica but still can go east to west and can end up at the same place. I mean, they end up making these little cycles. What are they going on? Winds that mythical winds that don't exist. So I've never been able to see how people could explain that.
Not only that, the biggest thing that disproves flat Earth is longitude and latitude.
Well, never mind that. Okay, see, that's a construct. Okay, I mean, technically, We could have just constructed something, but you can't construct a wind that goes from east to west. Okay, that's there or it's not there. So when you pick up a wind, whether you are going, on the same line of latitude, a human construct or not, doesn't matter in the end. If you're going to the east, okay, say, or to the west, you end up at the same place again, as they did when they actually took off in their balloon. And whether you know or you have any construct of latitude or longitude doesn't matter. They covered the entire globe and they never saw Antarctica. Okay, so how do you explain that? And you have to have real science to explain that. You can't just say, well, I think, no, that's not the answer. The answer is, it happened this way because scientifically this is what happened. And they don't have those answers.
Right.
They just have the, well, your mother's stupid. They go down the other path.
Another way to debunk flat Earth is you can pretty much ask any pilot, commercial pilot, and everybody says, well, they never do this, never do that. There is such thing called polar routes. They use them all the time. They go over the North Pole, they go over the South Pole.
That's right.
They do it because it saves time. There is no circumference that they go around. They fly over the poles all the time to get from point A to point B.
Yeah, and you don't even get me started about the Navy stuff, because my specialty with our models has been in the submarine industry a lot of the time. So, I've been in a sub as a guest, and I've been to sea, and I've again as a guest, not as a Navy personnel, and I know from the missions that go underneath the North Pole and in the Arctic that subs routinely go up there and surface, and they do these Arctic exercises. I was actually on one of the subs that went up to do one of those, but I wasn't on it when it went. I've been on the sub that did go up there, and that was the Alexandria. And I visited the sub down in Groton, New London, where I was doing a project, and they said, hey, you want to go see the sub? Yeah, sure. So I went on, met the crew, met the commanders, all that stuff. But that sub then went to the North Pole and surfaced under the ice. Boom, right up underneath the ice. So that was the Arctic, the North Pole. It wasn't Antarctica. So the question is, how do the flat earthers explain the North Pole? And northern sea ice. What do they say? Well, they're just mistaking it for southern sea ice? No. Because then Greenland's right near there, and Hudson Bay is locked in by ice, and, I don't know how you explain that. Where's this North Pole come from if it doesn't, exist? And then, how do they explain the weather patterns such that they could have ice around the edges and like that? It's like that. It's filled with such illogic that to respond to it, you almost have to say that you have to dispel science in order to answer the questions.
Which they do a lot of the time.
Yes, that's true.
So, I mean, as I said, I just wanted to throw something out there, give you a chance to ask a couple questions. And I know I've heard the whole circumnavigate, and go in a round circle, with planes and stuff like that. But when you think about it, that would involve hundreds of thousands of pilots over the years, and this big conspiracy. It's not possible.
Yeah, keeping the secret that doesn't exist.
And with the Antarctica being, and it's government controlled, so nobody can get near Antarctica. Do you realize the size of the military force that would have to circle the disk, if you will, to keep people away? I mean, you're looking at one ship that maybe can cover 8 to 10 miles of coast. Well,
I can save you time. The calculation was there has to be 10,000 ships if they're spaced, at a certain interval to keep everybody from getting to the Antarctic. Okay, now I can dispel that right away because I actually know someone who was stationed at Antarctica for a year, and she sent me photos of Mount Erebus from McMurdo Station. Okay, all these things, and she was in the military and flew helicopters. But the bottom line is that this, she had to leave out of New Zealand on a C-130, especially outfitted with skis to land, and she landed on the ice runway, which was the McMurdo Sound McMurdo Sound, the harbor, frozen. And what they do is they shave it and make it nice and flat, and they make it a runway. Convenient. But then there's these areas of Antarctica that are dry valleys. And these dry valleys are used by scientists all the time. Why? Because they're the driest place on Earth. And you say, well, wait, Antarctica's all ice. No, it's not. There are these dry valleys, for whatever reason, that are very dry. And they actually use these valleys to study Martian missions. And they do Martian mission planning and training there. So this is, again, it's readily accessible, as inaccessible as it is. And it's readily accessed, as infrequently accessed as it is. So Antarctica is certainly a place that you can go. You can go tomorrow. You can actually, for $5,000, you can take a plane out of New Zealand, and you can end up in Antarctica. You just got to be able to stay 4 months or 5 months, because the plane doesn't come back, and you have to have a real reason to be there. And the reason you have to have a reason is because it costs a lot of money for them to put you up.
I wanted to make the one last point about flat Earth, which, I mean, obviously we do not understand gravity completely yet. I'm sure, Mark, I'm sure you can agree with that statement. We know how it affects stuff and whatnot, but anything that's more than, say, 100 and some odd miles in space is automatically going to collapse in on itself. It's automatically going to form a ball because of its mass and, therefore its gravity. Nothing that you see in space that is bigger than 100 and some odd miles is anything other than round. It just doesn't happen.
And Keith's right about that. I mean, when you look at everything, the basic universal shape, the shape that the universe loves, is the sphere. Yep. Now, we see it everywhere we look. When we look at the moon is a sphere. And you can see that the moon is a sphere because it has a curved shadow. You can see the unlit side, which will be lit later on in its cycle, and a crescent moon when it's just rising. Okay, you can see that. Now, we watch, and see that this stuff is going on. Okay, but the Earth, there's other clues as to how the Earth is not flat, and here's a simple one: plate tectonics. We understand that we're sitting on top of these very thin, cooled magma, basically, sheets that we call continents. And then under the ocean, there are the ocean floor, which are part of these continental plates. And there's big gaps in these plates all the way around the edges of these plates, and those are called, obviously, the subduction zones and the spreading ridges, and places where, new crustal material is being made. It comes up from the interior. Well, how does that work in the flat Earth, and how can it? And the other question is, gravity wants to make the planet round, a sphere. So there is no known force that would make gravity work on a planar surface. Okay? And they always have to come up with all these extra things that are outside of normal scientific understanding to explain how it could work, because they don't have any clue. And when you end up talking to someone who believes the Earth is flat, in the end, and this is, sorry, Cindy, in the end, it really comes down to ignorance. And yes, it's ignorance. I'm sorry. Maybe it's because they don't know enough about science. Maybe they don't know enough about the world. Maybe they don't know enough about the natural sciences to understand why the universe loves a sphere. Okay, and I can understand that, actually. I don't chastise anyone for not understanding that stuff. After all, it's what I like to talk about. I like to talk about exoplanets and these spheres around other stars that are planets. Now, we see these things out there. We know they're there. So obviously that kind of gives us a clue that maybe they're here too. The sphere is part of us. Maybe we are the part. See, Cindy just said something that is telling. Okay, she says, on a spinning ball, wouldn't all the continents shift to the equator? No, they wouldn't. Okay, because the spinning ball has to. If we were to shift all the, let's say, what would it take to move all the continents to the equator? First of all, the Earth would have to spin so fast that the continental breakup occurs. All right, and that means Earth would have to spin a lot faster than the 1,100 miles an hour it's spinning now. Okay, so if the Earth was spinning really, really fast, and say we did get continental breakup, well, what's replacing it? Okay, what's replacing it? What when it breaks up, where's it all going? And why would it go there? Well, is there any reason why, is there any reason why they would go to the equator? It's almost like people don't understand how gravity works. Gravity pulls equally on you wherever you are on the planet. So if the world really spins very fast, then things will fly off. They won't go migrating to the equator. Okay? Because migrating to the equator means you have a mental construct in your head that says, you don't understand gravity. You don't understand that it's actually a force that's pulling down and normal to the surface, perpendicular to any surface you're standing on the planet. All right? That's how come. All right? And that is why if the Earth went really fast, then stuff would start flying off the Earth. Okay? It wouldn't go shifting to the equator.
And with that being said, that is where we will end the flat Earth education for the night. Just, I wanted to give a chance, and because I seen her in the chat. She's been pretty much respectful, and once again, we don't mind people like that. And I appreciate Daryl in the chat, as well as Derek going around, and anybody else that wants to give answers to some of the people that may have questions of how we know the Earth is round and whatnot. Appreciate it. So thanks a lot, mods, for that. So once again, we go back to Saturn, and he's getting there. We do have a couple high-passing clouds, that are kind of shimmying in and out here.
But Saturn's looking better than it did like a half hour ago, actually.
Yeah, I mean, it's getting better and better as it rises up in the sky. So that's it for the Flat Earth talk tonight. And I'm pretty
and
sure.
you're the one that said you're not going to give it a split second of attention.
I wanted to, because I felt that, as I said, I seen her in the chat, and I just felt that there was a chance to know, to actually answer somebody's legitimate questions that seemed to be maybe on the fence about it. And I wanted to give the other side of the story before, because there's plenty of flat Earth channels out there pushing pseudoscience and whatnot. So I just figured to give her the other side of the coin. That's all.
Yeah, and she's, she might be a victim too of what she sees on the internet, because sometimes these people say things very authoritatively. Yeah. Not her, but I mean the people that she's learning these things from, and you come away saying, "Wow, it must be true," because you made it sound so authoritative. And it's not saying that she's less intelligent in any way. It says that she was believing it because she was fooled, and that's just the way it is, And these people saying this are passionate about it. They believe this with all their hearts, and so when they say something and they're so convincing, this is why like Jim Jones convinced people to drink cyanide. Yeah. And why what is his name, John Doe, not Doe, what's his name?
Yeah,
the Hale Bop comic guy.
Yeah.
Convince people to die with Nikes on. It's like, come on.
But either way, I'd like to thank Cindy for watching, and at least she was open to some of the answers you were given, and that's where we'll leave it. Now, coming to Saturn's rings. You're talking about the separation between, let's put in layman's terms, the thicker and the thinner rings. At this point, that NASA has been doing dives through Saturn's rings. How many dives have we done so far?
I think they've done 2, haven't they? The first one was uneventful, and now here's what's interesting.
And actually kind of surprising too, wasn't it? Because they something was surprising about when they did either the first or second dive. They didn't hit it. Or
yeah. You're right.
Explain that.
Yeah, and the first dive, when they did the first dive, here's the thing: when the sun's energy and the energetic particles hit the ring particles, in concert with Saturn's magnetic field, you get noise, electrical noise from the particles. So you actually hear like static, like shh, okay, and that's the sound of ring particles that are emanating this electrical interference. So they hear the electrical interference, and they hear it as they go through the rings. Now, as they were going through the rings the first time, they heard like shh, and it got louder, shh, as the thing got through, and then shh, it faded away. Okay, and it took it several minutes to actually do this. Well, the second time they went through, it was like really quiet. I mean, they heard some, but not a lot. So that told us that actually Saturn's the density at different points in the rings does make a difference, and maybe it's possible that what we know about the rings still needs to be modified such that it's a little bit more understandable, because we don't have all the answers. And that was cool. I mean, actually just listened to that electrical thing yesterday, believe it or not, because I wanted to hear it, and and that reminded me of something that we're going to add to the John Zach Memorial Observatory. We're going to add a meteor radio, where we're going to be able to hear meteors coming in.
Sweet.
I sent that to you. I sent you the Skype information on that, because I think we should all do that. See, meteors, when they come in, they'll make a noise. With the ionization trail up in the atmosphere, they make a little noise. It's really kind of cool. Well, anyway, we do it when Cassini was diving through the rings. People say, "Oh, it'll get destroyed," and the problem is that we see the rings; they look solid from here, don't they? But when you get there, those ring particles are actually pretty far apart, and where you see the gaps, okay, that's not dark material; those are gaps, and those gaps come from other moons that actually help sweep out little areas in the rings and make them clear.
Well, a lot of people have a question: is the rings actually dust, or what's the biggest pieces you can expect in the ring system of Saturn?
Well, the rings are actually mostly icy particles. Okay, and these icy particles can vary in size. I think they vary in size from micron-sized dust particles all the way up to pieces that are fairly large. In fact, we know that some are actually several hundred feet across, because they're part of the Shepherd moon system. So there's various size particles in there, and it's some of these larger ones actually that do the sweeping and clean house basically in some of the areas. So that said, these rings are actually as dense as they look. They're not really dense, and so twice now Cassini's plunged right through there and never hit a thing.
And somebody asked in the chat, how long would it take to get to Saturn from Earth if you were traveling, say, normal, what we're capable of, normal spacecraft flight? What do you just comparative to, say, Apollo speed to the Moon?
Well, I mean, Saturn is over 700 million miles away. Okay, so if we say, how fast you want to pick for a speed?
I don't know. I mean, but basically the speed that, let's do it based on, we can do it a little faster than Apollo.
30,000 miles an hour?
About that. I'd say 20 to 30,000 miles an hour.
Okay, let's say 30,000 miles an hour, okay?
Okay.
At 30,000 miles an hour, then, it's going to take us 25,000 hours, okay? Now, if we divide that hours by 24, that'll tell us how many days, okay? And that's going to take us 1,041 days, all right? Divide that by...
So a little over 3 years.
Yeah, exactly. So divide that by 365, and it's 2.85 years at 30,000 miles an hour. Is that a little enlightening for everybody to show you? And I'm doing a calculation right here on the fly, just so you know. I mean, so if it's off a little bit, I'm sorry.
Right.
But it's about 2.85 years that it'll take to get there at one of the fastest speeds that we can go. Yep. That's in our own solar system, for crying out loud.
Yeah.
Jeez.
You're talking about almost 3 years to travel 3 planets away.
Yeah, 750 million miles.
So, comparative wise, just to show how far apart at that same speed, let's go one further. Like, how long would it take to get to Mars at that speed?
Mars?
Mm-hmm.
Let's see. Okay, let's see now. Okay, Mars. Okay, and I'm just going to do the distance to Mars calculation here first, so to get that. Mars is actually obviously a lot closer, but let's see.
Well, that's what we want to know. We want to do a comparative of actually how far away
the
planets are from one another, not only us. You know, you're talking about almost 3 years to get to Saturn. Comparatively, how much closer is Mars? And then we'll do Jupiter after that as well, too.
Yeah, Jupiter is 360 million miles away. But now, here's the thing. Okay, Mars is sometimes closer to us than other times. So we want to.
Let's do it at perigee, and then we'll just base it off of that.
Okay. All right, so let's pick, all right, 47 million miles then. Let's use that. We'll say 47 million miles. Okay. So at 47 million miles, if we look at that and we divide it by the 30,000 miles an hour, okay, then we're looking at 1,566 hours, right? Mm-hmm. And we divide that by 24, and that's 65 days, basically.
Okay, so you're looking at a little over 2 months to get to Mars, compared to almost 3 years to get to Saturn. And I'm pretty sure somewhere right in the middle of that for Jupiter. Depending on the distance between Mars and Jupiter and Saturn and Jupiter, but you can pretty much plot that somewhere near the middle of that. So, yeah, I mean, you're talking. I mean, it really makes you appreciate how far away our planets are and the strength of the gravity of our sun to keep everything orbiting around it.
Oh, I know. And you say the strength of the gravity, yet gravity is like a very weak force. So I mean, you can relatively easily overcome it. Right. There's some nuclear forces that are far stronger. So it's kind of weird. How this all works. When people think about this. So now, if you take the fact that that's Mars and Jupiter, you said it's like 365 million miles. So you just have to, kind of just come back from Saturn a little bit on that. Saturn is 66 light hours, 66 minutes, right? And Jupiter was 30 minutes, so roughly half. Mm-hmm. So the same kind of thing. So you can come back on that mentally. You can figure it out. Right. But that's pretty cool. That's pretty cool. And I just think that when we look at Saturn, it's really interesting to me that we see it in a delay. You think the YouTube delay is bad. Okay, Saturn is an hour and 6 minutes away by light speed.
Yeah.
Now light moves fast. That light moves so fast that if you could make it go around the Earth, it would go around the Earth 7 times in a second. Okay, the same beam, your little light packet would get around the Earth 7 times in every second. Okay, and it still takes over an hour to get to Saturn at that speed.
And a question from the chat from Roy Jenkins. It says, would the magnetic field of Jupiter protect you from highly charged particles if you try to space travel?
Well, see, it's the magnetic field of Jupiter that is precisely the reason why it has such a high radiation field around it, and it's the reason that we have a Van Allen belt too around Earth, not Jupiter, but our magnetic field traps energetic particles from the sun, and that creates a Van Allen belt, the radiation belts, which kind of mirror our magnetic field. Our magnetosphere, and the Van Allen belts sort of are mirrored, and in the same way, Jupiter's magnetosphere traps radiation, but much more of it. And so, for instance, Io is bathed in this heavy radiation, as are some of the other moons, and same with Saturn. But the bottom line is that it wouldn't protect you; it would actually most assuredly kill you. It's exactly the opposite.
And another question from chat from Lacey. It says, is it true that we know more about space than we do about our own oceans? Is there ever going to be any focus on what's under the waters?
We're always focusing on what's under the waters. I used to, I did a presentation for the Woods Hole Oceanographic Institution where I actually I had created actually a model of the Alvin submersible that was fully functional. It dove, it could go down and see things and do stuff. And it was a little 24-inch long or 30-inch long model. So I was showing them that thing, and I became intrigued by oceanography, and I started to talk to them. I went up there, stayed at the scientist's house for weekends, and really got to explore the new technology that they're using. And I can tell you this: inner space exploration, that is the exploration of the ocean, is definitely not fully known. We don't have the full understanding yet. But what we do have in space is far less of an understanding as from anything else. Now, we do understand the things we can see with our telescopes, all right? But keep in mind, we only understand about 4% of the universe. The other 96% is still something beyond the reach of our current physics. Our standard model of physics can only dictate terms for 4% of the universe. But with that 4%, we've managed to get to other planets, and we've managed to go on the moon and leave our flag a number of times. But in the ocean, you don't think there's any oceanographic achievements. But I encourage you to go look for some of the live streams from oceanographic expeditions that are out there, because you can go right now and look and watch the ocean floor on some of these oceanographic expeditions and hear scientists make commentary on these new creatures they're finding all the time. So we are learning about the ocean floor. It's just that the ocean, requires a different sign on your pressure equation. It requires you change the sign from negative to positive when you're calculating pressure. And your devices that go underneath the ocean here on Earth have a very different requirement, but we've got more of them than those that are going into space, because space is expensive to get to. Just to go from ground level to 200 miles and make sure you're in a circular orbit around this planet minimally costs you just like $25 million. So I think that when you look at that cost, you can certainly get, you can certainly do oceanographic study for far cheaper, and we do. That's going on all the time. Yeah, there you go.
Interesting. I'm looking, kind of going through the chat and seeing if was there any more questions. Going back a little bit. What time? Oh man, it's 12:30 already, huh? Wow, we've been on that long.
I kind of talk a lot, I guess.
Wow, we've been on 3 hours already. Didn't even realize it.
Yeah.
So let me do a little brightening of a Saturn here, just to it's gonna flush it out a little bit, so you won't see much of the actual banding on Saturn, the planet itself, but it will give you more of an idea about the rings. When I bring the brightness up a little bit, it kind of flushes it out, but it doesn't look too bad. And you guys will see it here. Well, you guys are seeing it. Gotta stop doing that.
Yeah, right.
All right. So, any other questions about Saturn? Once again, feel free to ask them in the chat. I'm trying to keep up with everybody. Once again, actually, let me do some chat shout-outs, because I know there's a whole bunch of people here. I'm just going to go through the list of active participants. That way we can just say thanks to those guys. So we got Armand and Blaze and Brenda and Byron and Dabble and Daryl and Deidre and Doug. I haven't seen Doug in a while. Good to see him back around. Drake and Duplicate, of course. Let's see, Fantasy and Dramaticus and Horror Godzilla and J Quest and Jay and of course Jenny and Just Ain't That Way and KJ
and Byron
and Lacey Lou Who and Mick and Michael Overmeyer and Nate Saving and Quantum Particle Wave.
And Cutie Peridot.
And Rockstar, Rodney, Roy, Sea Pirate, Spherical Earth, Super Hammy, Ted Bronson, Tina, I'm guessing that's Tina. Tenna or Tina. I'm not
Books
sure
and Skin.
Pronunciation. Tony the Night Owl, Traxlin, and Smoke 'em. There's my list of active participants now. If I missed you, sorry. I'll probably see you in the chat. But there's a list of active participants that we have. So welcome to everybody, and welcome to class. There will be a test later.
Oh,
make sure everybody was paying attention.
do I have to take it to?
So okay, what's the craft that went through past Saturn? I think it was Cassini.
Yeah.
Yeah. Now I'm trying to remember here if my brain is still functioning. Was Cassini the little satellite that could? Is that the one that we got so much information from that we didn't expect because it just kept, just sending amazing stuff back?
Oh, that might have been like one of the Voyagers, actually.
Oh, okay.
It left, it got into the the heliopause. It got out where the sun's influence finally was, not felt anymore. Mm-hmm. In other words, it left the solar system fully. I mean, that's pretty amazing. And that was sending back signals, weak signals though they were. But that was pretty impressive that it could be out there doing this. I mean, that if that's what you're talking about. Mm-hmm. Cassini, though, Cassini was almost a satellite that never would get up there because of its nuclear reactor. They were afraid if the rocket crashed that it would, cause this radioactive fallout, basically. And they had to spend just immense amounts of time proving that under all conditions. I mean, they tried to destroy the containment vessel over and over and over, as a sample one, obviously, to show that this thing could withstand anything, So,
do you want to answer this question? Yeah, I'll let you do this because I've answered it enough over the time. But hey, Mark, why can't we see stars right now with the image that we're showing on the screen?
Well, I mean, the answer is actually it makes itself evident when Paul increases the exposure. As he decreases the exposure and makes the image brighter, then you see the moons. You should also be asking, why don't we see Saturn's moons? But we know they're there. They show up, but only by overexposing the planet. Why is that? Because the planets are darn bright. And what you have to do is you have to stop down or limit the amount of light coming through to show the planet in a reasonable way. That's what we're seeing here. That's why Saturn looks so nice. If he was to then open it up and bring in more light, then you'd see those little tiny moons, okay? Some of which are brighter than the stars, okay? And then you might actually see stars if he had a wide enough view, all right? So that's the only reason you don't see him, is because the planet itself is very bright, and right now we're shooting with the cameras, we're shooting to see Saturn, not the moons. Even Saturn's moons don't show right now.
Okay, and then Mr. Nightman has a question from the chat. It says, are we any closer to developing technology that doesn't involve rockets that use crazy amounts of dirty fuel to launch into space?
You know what? I wish we were. But right now, chemical rockets are basically the only game in town for us. There are some engines that are being tested, but those engines can't get us off the planet. They can only be used in a cruise mode when we're out in space. Certain ion engines would be worth it when we're trying to leave the planet, though you can't use those. The microwave, that microwave engine, the one that uses apparently no fuel, kind of a thing. That little engine is interesting, that motor, because it's using this thing where I think it's related to the Casimir effect. I have to look at it again. But that is an engine that doesn't use fuel, but it uses a phenomenon that's associated with a certain configuration within an engine. So if that's the case, you would say, well, why can't we use that? And the answer is because it doesn't generate enough thrust. it generates thrust if you want to build a light speed, craft that goes near light speed someday. But it'll take it a long time to get up there, and you have to already be in space with it because it could never generate enough thrust to leave the planet. We have a escape velocity from this planet. Our gravity is pulling down on you at 32 feet per second. That's the acceleration due to gravity. It's minus 9.8 meters per second squared. Now, you have to overcome that to leave the Earth. But you actually have to put yourself into an orbit around the planet. In other words, controlled falling, so that you're moving out and falling down at the same rate that you're also moving horizontally, so that as you fall, you're going to continue to move in a circle around the planet. And to get into that orbit requires something with a lot of thrust. Now, it's possible that someday we might have an Alcubierre engine. And the Alcubierre engine is, of course, the warp drive. And warp drive is something that was in Star Trek, and people say, oh, well, that's not real. And it wasn't until 1994 when Miguel Alcubierre came up with a concept for literally warping space, essentially contracting the distance between you and where you want to go, and lengthening the distance between where you were and where you are. So if it could do that, like fold a paper over it to corner, and then step across the gap and then unfold it, okay? You traverse that distance without actually traversing the whole distance. Now, that little metaphor in your head, that's actually something that is under investigation by NASA. And the reason is because when Miguel Alcubierre came up with this concept, the Alcubierre drive to make the warp bubble required taking the equivalent mass of the planet Jupiter and converting it to energy. So it was a stupendously colossal, absolutely insurmountable amount of energy that we simply could not possibly generate, nor we figured that not even a very advanced extraterrestrial society would be able to do. So it seemed impractical. However, when when experts actually modified the ring around the ship that the Alcubierre warp drive would be part of, they found that they could optimize it. And they optimized it such that it didn't require the mass equivalent of Jupiter, but the mass equivalent of the Voyager spacecraft. It was like a 10 to the 26th reduction in the amount of mass required. And thus, that made it distantly plausible. And that's why NASA is looking at it, because it's actually got some plausibility now. Isn't that crazy? That's crazy. This is, dude, it was science fiction, dude.
Yeah.
And now
I think we chase science fiction, fact. Believe it or not.
No, I think that our brains can't think of anything actually that's inherently impossible. And so when Gene Roddenberry thought of warp drive, of course, he had talked to scientists about the potential for a warp drive and what it would mean. And we didn't know anything about what's called the fabric of space-time back then. We didn't know a lot. And we have a better idea about it now. And we still don't know much about it. The more we know, the less we know, kind of thing. But in the end, when we look at what the Alcubierre drive could do, it's actually effectively the warp drive. But that's still way too slow if we want to explore the galaxy. Right. Because at the fastest speed that the Alcubierre drive could get us to, say, Alpha Centauri, in a trip that would otherwise take 19,000 years with the fastest travel we know now, a trip with the Alcubierre drive to Alpha Centauri would be done in 5 days. Okay? 5 days. I mean, that's a short trip, But like when you acquire bugs in your windshield as you drive, so too the Alcubierre warp bubble would acquire energy particles and stuff along the way that would pick up along the way. So much so that by the time it got just to Alpha Centauri, the amount of energy it would release when it stops and sheds all that excess energy that was on that on the warp bubble, so to speak, windshield, would literally destroy the whole solar system, including the Alcubierre ship. So they have to actually make this trip a little slower so they can actually bleed off that excess energy. So a more realistic trip time would be like 3 weeks.
Yeah.
And if they did that, then great, it works. So a 3-week trip to the nearest star, wow, sounds fantastic. But what's the next nearest star? Oh, about 10 light years. Oh, how long is that going to take? That's going to take about a month.
Yeah.
So we're going to be quickly back up to astronomical time frames, even with the Alcubierre drive, a warp drive. So we want to get around that.
Distance
and to get around
is just,
that,
it's just mind-boggling when you start thinking about astronomical distances and whatnot.
Right.
Okay, but what we're going to do right now is we're going to take a break. It's a 3-hour mark, so we're going to be a bathroom break, smoke them if you got them, whatever you want to do. And then when we come back, we will do the last stretch of the stream and then go from there. I'm not sure. How's your skies looking up there, Mark?
I'm clouded up.
You clouded up? Okay.
Yeah,
So,
I'm clouded up.
So that's what we're going to do. We're going to take a break, and we'll be back in about 5 minutes or so, and then we'll hit the home stretch of the stream with Saturn and with Mr. Marc D'Antonio. So, guys, we will be right back. About 5 minutes or so. We'll be back. are back.
Hey,
nice break.
We're back.
We got some food. Everybody smoked them and peed and whatever you had to do. We're probably going to run the stream till about 1:30. So this is the home stretch. And what I'm going to do now is I'm just going to let Marc go ahead and just feed you some knowledge about Saturn. And basically just you could take this as a lesson on Saturn. He's going to hit the main points that people should know. And then maybe at the end we'll have time for a couple more questions and whatnot. So, Marc, feel free to take it away, bud.
You know what? I like to. Sometimes it's fun to do these little riffs on the planets because you always find yourself going down a path that you just don't expect. And one of them was when he overexposed the planet, you started to see the moons a little bit. That's just you were just seeing 4 or 5 of the 62 moons. I mean, there's so many more moons. But I want to talk about a little bit about why the moons actually end up in this arrangement that you see. And you have to understand that when a moon is going around a planet and another moon is a little farther out going around a planet, those 2 moons interact with each other every time. They actually, the one that's closer to the planet goes faster around the planet because it has to maintain its orbit around the planet. And that's what's naturally occurred over all this time. It has maintained the orbit by actually speeding, having a speed that keeps it in the orbit. And when another moon passes around the outside of it, all right, that moon, as it's approaching that other moon, tends to retard the motion of the moon. And then as it passes the moon, tends to start pulling it a little bit. That's what happens, as I mentioned before, between Enceladus and Dione. Dione, a little farther out, pulls on Enceladus and kind of made it into an elliptical orbit. That's the reason that Enceladus has the oceans, etc. We talked about the hydrothermal vents and all that. Well, anyway, these moons, over billions of years, have settled into this pattern, and it's called a resonance. They're actually in resonance with each other, meaning that for one moon that's in the inner, closer to the planet, it might circle 4 times to the next moon out, only going around twice in the time the other moon went around 4 times. We see that with Jupiter, with its Galilean satellites. There's a resonance there. All right, it's a 1-2-4 resonance where Io goes around 4 times, and the next moon goes around twice, and then once for the other one, etc. That resonance sets up, gravitational interactions with each of the moons that become endemic to what goes on in that system with those moons at that location around the planet. And that's so when we see Saturn actually going, when we see all these moons around Saturn, every one of those moons interacts in one way or another with every other moon, even in a minuscule way, but it's in a way that is stabilized. Now, you can do what, from the beginning of the stream, Keith and myself, we talked about Universe Sandbox and Universe Sandbox 2. There's your programs you can download from Steam or for the PC, and I don't know if they're made for the Mac. They probably are. And they allow you to tweak parameters. So you could take the Saturn, the Saturnian system, and you could create it and say, now what happens if what would happen if Enceladus was actually the size of Europa? Enceladus is only 300 miles across. Europa is 1,920 miles across. So what if Enceladus was 1,920 miles across? And you change the parameters and then watch the difference. You would actually see that you're made to stabilize the orbits of all the moons. And some of those moons might end up getting gravity whipped out of the Saturn system. And that's something that happens and has happened over time. Maybe it was a gravity whipped moon that was taken too far inside the Roche lobe of the planet Saturn, which became the rings, as someone suggested in chat earlier. I think it's actually that the rings never coalesced into a moon because they were already within that limit. But if you think about it, this is a dance. The moons are in a dance around the planet, and they're all supremely dependent on each other. The gravitational perturbations, or the little gravitational massages, so to speak, that each moon does on the other, are important and necessary for those moons to stay exactly as they are. But that's the nice thing about the universe. It doesn't really change so much. It stays the same. The only time things really change is when a comet comes in and dislodges something or causes a problem. Even a comet like Shoemaker-Levy, which collided with Jupiter. As it approached Jupiter, it broke up into many, many pieces, which rained, real havoc down in Jupiter's atmosphere. And I even saw the black spots appearing on the cloud tops of Jupiter with my telescope. I was watching an event happen live as it happened, and I saw them hitting. Now, it takes hours for all that stuff to come up, and start to show itself. But I waited, I watched, I followed it for days. Well, in watching this stuff happen, you say, wow, did that comet affect the orbits of the other moons? Well, the comet had gravity, and so those moons were affected, but not enough to actually be moved from their orbits and dislodged, and nothing catastrophic. It didn't collide. It didn't cause any problems when it hit. But you see, if a large object, say a Kuiper belt object, remember Kuiper is spelled Kuiper. It looks like you want to say Cooper belt. It's Kuiper belt. If a Kuiper belt object was dislodged for whatever reason, say a star passing nearby a million years from now actually dislodges an object in the Kuiper belt and starts sending it on a long, slow, spiraling path into our inner solar system. As it comes in, those inhabitants in the far future would probably notice that the planets are being perturbed by something. And at that point, they would certainly have the technology to either stop it or utilize it. Utilize the energy, steal the energy from the incoming object, or change its trajectory, any of that, or any and all of that possibly. Now, if that was the case, but let's say they didn't, they might notice, say if they were at the same technological level as us, for whatever reason. If they did that, they would notice that Saturn's moons would start to look like they're having orbital changes that are unexplainable. And Jupiter's moons might be doing the same. They might notice that Pluto has a variation in its orbit. If it was actually on that side of the solar system at the time where the object was coming in, it's possible that Pluto would show some type of perturbation and change in its orbit. And this would be a true, Planet X event, a true, the true Nibiru that would actually, be occurring in our solar system if such a thing happened. But it would literally have to be many, many years, probably millions of years away in happening. And then the reason is because right now there is nothing perturbing the Kuiper belt in any dangerous way. There's no stars close enough that are causing anything, not even anything that you can say might do it. Nothing that close. The closest star system is the Alpha Centauri star system, and that's 4.3 light years away. And that's just a little tiny red dwarf. The A and B components are a little farther away.
And Alpha Centauri is smaller than our sun, correct?
Well, actually, A and B, it's a three star system. It's a triple star system. A and B are kind of like our sun. They're about our size. But C is much smaller. C is the little red dwarf. Mm-hmm. Okay, and that one is smaller. And that's the one, by the way, that we actually found the planet around. So that's pretty cool. So Alpha Centauri is a even that star isn't close enough to cause any problems and perturbation in our Kuiper belt. But see, that's the danger to our solar system, is if something comes along, an interstellar interloper, comes along, causes our Kuiper belt, or the Oort cloud, which is even farther out. The Oort cloud is a spherical cloud around our solar system that has, they call it the realm of the comets. It's a really romantic sounding name. but it's actually a location from which all the comets tend to come. And those are the first things that will feel a perturbation that would bring them into our inner solar system. So if they're orbiting the solar system, kind of like, as I've said in my streams, globular clusters orbit our galaxy. They're halo objects. They're out there orbiting, in a variety of ways, not planar like moons around a planet or anything, but like any old way, spherical halo around our galaxy. Well, the Oort cloud's like a spherical halo of comets around our solar system, and those would feel these perturbations first, like a passing star or whatever. When I say passing star, understand I mean a passing star, because stars are all moving through space as they orbit our galaxy. It takes us around 230 million years to go around our galaxy once. Well, the other stars are orbiting too. If they're farther out, they orbit at a slower rate. When they're closer in, they orbit at a faster rate. At our location, 2/3 of the way out, it takes 230 million years. So a star passing near us could perturb comets into our inner solar system. But as far as the Kuiper Belt, which is a lot closer to us than the Oort cloud, and that's Oort, O-O-R-T, that's how that's spelled. I know, it's a weird name. But the Oort cloud is named after a guy that found the Oort cloud. And this cloud is a bellwether that could tell us if something was something large was out there coming toward us. And but we wouldn't know. Again, this takes place that would take place, say, over hundreds of thousands of years, where something would be passing close by and we would notice perturbations and we'd find this object, 500,000 years from now, way out, heading down through the Kuiper Belt, and we could say, oh, well, that's going to be here in about 600,000 years. So you're still well over 1 million years before you even have to worry about it, But that's our solar system is more than just planets. That's the point. And the outer solar system is that Oort cloud, like I said, and many, perhaps billions of cometary objects out there.
Do you think the hardest thing in astronomy is getting used to the actual size and the distances of, astronomical terms?
Yeah, absolutely. In the first chapter of my book on exoplanets, the first chapter is called "The Problem with the Numbers," and I talk about how we look at, like, to us, our world is our crib when we're babies, and as we get older, our bedroom is our universe, and then older still, our backyard becomes our universe, and then, oh no, we can look through a hole in the fence to the other universe available on the other side of the fence. Wow. And we move outward that way as adults, as we age, as humans. And then we look to space. Well, in that chapter I talk about this as it's a real problem, because even when you want to talk about a scale model of the solar system alone, just the solar system, you have to go into astronomical numbers in order to do it. For instance, if you made the sun, say 3 feet across, Pluto is not just 300 feet away. Pluto is many thousands of feet away. And if you made this solar system the size of a saucer, like a 5-inch saucer, solar system, I'll just say Pluto, the nearest star is in Washington, D.C. at that scale. So, you're looking at this vast universe, and to apply it in a reasonable way, we need faster interstellar technology. We need interstellar technology, period. But these numbers are so big that you just get used to using them. You talk about things in terms of light years as opposed to hundreds of thousands of miles. The moon is 240,000 miles away, say, okay, on average. Well, that's 240,000. But the human brain can't really comprehend more than 1,000 of anything. And for instance, to show how many people died in the Titanic, I might have mentioned this. They said, well, over 1,000 people lost their lives in the Titanic. But to show that, they had to take 1,000 people and put them on the dock that the Titanic left from. And when they did that, they actually, that struck home. And people saw 1,000 faces looking back at them on this photograph on the dock. And that's a nice super zoom, by the way. Yes, I agree with that. Saturn. So
yeah, I'm actually kind of I'm doing that in post, trying to keep up with Paul. I'm just seeing what was possible while you're talking. I'm kind of just playing around with it.
No, I heard you in the background. I didn't care. I thought it was great.
Yeah,
it's good. So,
but that just goes to show how good his tracking is. That I can leave that. Like you'll see it drift off a little bit from center here.
Yeah, but still, that's good.
Yeah. I'm sorry. Go ahead.
No, I was just saying. So, numbers are astronomical, and it doesn't take long to go into astronomical numbers. You know, even if you want to make a model. And here's another. This is a little one, a fact that's interesting. The nearest star system, Alpha Centauri. You know, those stars should be disks in our sky if we had a telescope that could look there. Okay, but they're so small that they only ever appear as points of light, and because they're points of light, that's why we get that atmospheric flickering that you were talking about earlier. That's called scintillation, and that disturbance to the atmosphere doesn't have to be much, but stars will look like they're flickering because they're point sources, and it's much easier to disturb a point source than it is to disturb a distended source like a planet, which has got some size to it, some angular size in the sky. That's why planets always look like they're not blinking. Okay, but stars do. All right, and that's an elementary way to tell the difference between a planet and a star. You know, planets look solid, don't move, and don't flicker, but stars do. So that said, because the stars are so far away and they only ever appear as points of light, if you want to see the disk, say, of Alpha Centauri A, the larger component of the triple star system, you would have to have a telescope that would be able to see the face of a quarter at 750 miles.
Wow.
Because that's how far away and how small the disk is. That's an equivalent measurement that I did. So it has to be 750 miles away, and you have to be able to see that quarter from that distance. And if you could, you'd see the disk of the star. So that gives you an idea of the task that we have. Now, keep in mind that planets are between 10 and 100 times smaller than that, and we're seeing planets around stars that are thousands of light years away. And you say, what? How can that possibly be? And that's because, obviously, that we're seeing other things. We're not seeing the actual planet. We're seeing the effect the planet has on the star light, where the light's dimming.
Right.
So I think that kind of brings into perspective just how much we understand with just the light from a star. We can use the light from a star to decide or to figure out what the star is composed of, whether there's anything circling it, whether the star is having any kind of bursts of radiation, or whether the star is in its final stages, whether the star is surrounded by a shell of gas that's hot or cold. We can tell all these things just by looking at the starlight from a distant star. And in a future stream over on Sky Through a live stream, what I'm going to do is set up my spectral capabilities, and I will be taking spectra of the stars using our special camera. And we're going to be able to see all of the spectra of these stars, and I'll be able to explain what we're looking at and how come this tells us information that is valuable to us. Okay, so aside from the physical properties of a star, like its diameter at this distance or whatever, we don't have that to play with on a daily basis with stars, so we have to look at the light from the stars, and that is a whole nother science. Okay, it's called spectroscopy, and I did massive amounts of spectroscopy to be able to identify certain stars that were speeding out of our galaxy at high speed. I had to take the imagery of these stars, and then I had to reduce the data. It's called. I had to take into account where it was in the sky and how much air we were looking through. That's called air mass, and get rid of that. And then I had to account for the reddening caused by the atmosphere, because when you look at Saturn here, it's sort of a. I know you're modifying the colors slightly, Keith, but Saturn generally looks yellow to your eye, and it's a little bit brighter than that, a little whiter than this yellow, that you see in the sky.
Let me fix that for you there, buddy.
And we'll see it in 30 seconds.
Yeah, we'll see it in 30 seconds.
But the point being that brightness that you see of the planet in the sky, okay, it's always shifted toward the red, just a little bit. And that's because our atmosphere loves to scatter blue light. If you ever looked at a full moon, you see the sky around the full moon doesn't look red, it looks blue. It's sort of a bluish color. That's because the moon is reflecting sunlight, and sunlight gets scattered. That is to say, the atoms in our atmosphere love to absorb the blue light from the star that's coming in, from any star that's coming in, and then it spontaneously reflects it. Not reflects it, but emits it again, but in every direction. So that's why we have a blue sky everywhere we look, because it's a random emission of this blue piece of the spectrum everywhere we look. So the sun's light in our sky looks a little more yellow than it really is, toward the red. So every star you look at in the sky, especially those on the horizon, every star you look at is just a little bit more toward the white end of the spectrum. All right, a little more brighter, a little more toward the higher energy end than you're seeing it. Because the Earth is fooling you, because you're looking at it from underneath an atmosphere. If you're out in space, the stars look very different. The orange star Antares is a red giant. It's certainly not the biggest red giant, but it's a red giant. And that star looks very orange to us. Up in space, that star is still orange, but it's actually almost more of a brighter orange. It has a more of a whiter orange to it. It's a lightened up a bit because it doesn't have any of this scattering going on. Now that scattering that our atmosphere does has a special name. It's well understood. It's called, yes, exactly, Daryl, Rayleigh scattering. That's right. I just saw that as I was reading. And Rayleigh scattering is responsible for the blue light that we see in the blue sky. And it's also responsible for the blue light around the moon that we see. And so we have all the observations we make, all the astronomy we do, we have to take into account, if we want to get real data, accurate data, we have to take into account this reddening caused by our own atmosphere. We also have to take into account what's called extinction. And that doesn't mean the dinosaurs are dying again. What it means is extinction means extinction of the light, meaning the light is being reduced and attenuated on us when we look at something, if it's at a lower angle in the sky, like Saturn was earlier in the night. It was lower in the sky. So that said, we have to account for all those things. But this is what happens when you're trying to do real science here on a planet that has an atmosphere. And it's also part of the reason why really high-end observatories are way up on top of mountains. They're trying to get up above more atmosphere to give themselves a more stable view, a better view of the sky, and another way to see the night sky without all of the attendant water vapor that's going to be in the atmosphere that's going to affect their sightings, affect what they're going to see, and without all the attendant aerosols and hazes that may appear at the lower levels, and they can be above some of it. So the higher they can get, the better. Ideally, if every observatory could be up in space, it would be the best. But we don't have that option.
Yeah.
So, and that's sort of, we kind of riffed on a bunch of things there, but it was primarily interesting to talk about, what we're with Saturn and the colors and stuff. I think the colors of the sky are very important.
Yeah, I tried to adjust on this, and the problem is I'm looking at it on 3 different monitors, and each one it looks different.
Well, that's your monitor.
So I'm not sure. Yeah, I'm not sure what it looks like. I think I got it to the yellow whitish look.
Yeah, it's pretty good. I think that and that's the other thing too, and I gotta just make a mention of that because you actually bring up a very good point. These monitors that we use, these computer monitors we use. Hang on. Someone's at my door, and it's what, 1:30 in the morning.
Okay, Raggy. Someone's at your door at 1:30 in the morning?
Yeah. It was my son. I locked him out.
It's the government, Mark. Run.
Hello, Gabe. Hey. I didn't know you were out. I forgot. It's all right.
Hello.
Anyway. So where was I? Oh, yes, I was over here. So, where was I?
Connecticut.
Thank you.
You're welcome.
I was talking about, I know I was actually saying this before, but I got sidetracked. I think you actually did a good job in getting the colors of Saturn.
Yeah, I mean, I'm looking. I kind of comboed the 3 different monitors I'm looking at, and this seems to be the closest to on all 3. So,
well, see, my point was that when we're looking at monitors to do our research, for instance, we actually have to color calibrate the monitors, because if we don't, then we may not be seeing what's actually accurate for the view. And so we had to take, for instance, we have these machines, these little monitor machines, and you put them on your monitor and you run them through this program which calibrates all the colors, and it tells you, okay, change your monitor's red sensitivity or your blue sensitivity now, do this, move it to here. And when you got in the green, say, with all of them, then you knew that you were good. You knew you were right where you had to be. So that's something you have to do if you're going to do the research of any kind. You need to do color calibrations even on your computer equipment to make sure that it's seeing what the instrument is seeing. You see what I mean?
Mm-hmm. Cough, cough.
Exactly. That's why I muted it.
Yeah, you can tell because the static goes out a little bit on it.
Yeah.
But
well, no, I'm sensitive to the fact that people were saying they're having to deal with my coughing.
Hey,
I understand, man.
Yeah,
I understand.
Well, with as much talking as you do, I don't blame you one bit. But I will say to anybody now, we got about 15 minutes left or so. If you do have any questions that don't need to go really far in depth, if you have some basic questions about Saturn, Jupiter, anything that we talked about tonight, feel free to ask them in the chat now. We're both watching the chat, and maybe we can just run down them and answer what we can.
What color is Saturn? Saturn is yellow.
Question answered. So, and Paul just actually messaged me and said the air is settling a bit, so it might actually get even clearer than this. And if it does, I'll try to get Saturn up in the full screen with a little less pixelation and whatnot. So, so yeah, if you have any questions, ask them in the chat, and we will we'll try to get to them. As you can hear, he's yeah, he definitely wants to remind people Moon returns this week. He's ready to go. Yeah, he said air settled a bit, clouds cleared, Moon returns this week. So, yep, it seems like we'll hit this moon cycle, hit the ground running with it, and hopefully the weather pattern stays where it's going to be nice in southern Florida. And of course, we won't be the only one. Once again, Marc's channel, he'll be doing it throughout the week, I guess, whenever he can. I have been posting the link to the channel in the chat pretty much all night. All you need to do is click there. That takes you right to his channel. You can hit the subscribe button if you feel like getting educated and learning more and more and more every time, because it's almost impossible not to learn something when you head over to Marc's channel.
And maybe we can have Clem Puckett do some instruction at some point.
So here we go, Marc. right down the line. Actually, starting right below your comment there in the chat from Tenna or Tina. I'm not sure how she's pronouncing that, but it says, "Why don't the rings get pulled in?"
Because they're orbiting, like our moon orbits the Earth. The moon doesn't get pulled in. In fact, it's leaving, and the moon's circling away from the Earth at like 2 centimeters a year. And the rings are actually in a stable orbit. That they've worked that out over billions of years. They've actually settled in. And each ring particle has an orbit of its own. And there's also moons within the rings, which shepherd, as I mentioned earlier tonight, shepherd some particles in the rings and also cause some of the gaps you see in the rings.
Mm-hmm. All right, and then we got one right after that is, how fast is Saturn spinning and how many moons does it have?
Well, it has 62 moons. And I don't know its rotation rate offhand. I guess that's something that I do know its rotation rate. Hold on. Okay. If you want to bring up another question while I'm doing that, I'll get the answer. I know what this is. I know the answer.
Sure. Ted asked, does Saturn have a rocky core?
Yeah, most likely. And, it's going to have a metallic hydrogen outer core at least, and just like Jupiter. But it will definitely have probably a rocky core, as will Jupiter. It might be small, but it'll be there. There's no doubt.
All right. And we have... Let's see, I kind of accidentally skipped ahead real quick. Do you have access to any infrared satellite images? I personally don't.
I don't. I mean, I do have infrared system, 2 of them, but I don't image satellites with them. I guess I could, but I don't really want to. That's Mr. Walson's claim, I think, isn't it? Yep. We got to get him on here. But go ahead.
And Ricky asked, where are the stars? We explained that earlier. When you expose the planet, it has everything to do with exposure. If we were to blind out Saturn and really pump it up with the white, you'd be able to see stars and whatnot in the background with it. It's all about exposure. Let's see. And Saturn's the one with the hexagon at the pole, right?
Yeah.
Yeah.
That's a weird resonant feature that occurs on Saturn, and it has that hexagonal shape, and it almost looks looks like a artificial creation, but it's not. It's actually just the way the gravitational interactions and the cloud interactions, the weather patterns on Saturn interact as Saturn rotates on its orbit. So I don't, it's a neat feature, but we also had similar but different patterns on Jupiter that were, not something that was readily explainable as well. So.
Meadow asked, are the storms that make it appear to be spinning like Jupiter? Are they storms?
Saturn is a little bit more bland than Jupiter in that regard. Saturn has its spectacular ring system. Jupiter has a ring system too, of course, but it's not as obvious, obviously, as Saturn's. But we don't see on Saturn any large-scale storm systems, but it does have cloud bands. They're just similarly colored, and they do rotate at a fast rate of speed, just like Saturn does. So we do have it does have that same thing. It's a little bit different than Jupiter's, of course, because Saturn's is a little bit smaller, but Saturn's also lower density. It's sort of like the lightest planet in the solar system in that regard. It floats like a cork, as I said, in water.
It seems Vincent is obsessed with infrared telescopes and whatnot. But do we have access to infrared telescope? I guess you could pretty much make any telescope infrared depending what your viewing device is, right?
Yeah, but keep in mind that glass is a great stopper of infrared. In fact, if you put an infrared sensor at the end of the telescope, you wouldn't see anything, ever. Because you don't get infrared light passing through glass. So anyone who has an infrared system can prove this to themselves just by looking through a window. Say you have a fire right outside your window, a fire pit. You say, I want to see the fire pit. You shine it at the window, your infrared camera looks out the window, and you just see this featureless gray pane. It's like, where's my fire? You're not going to see it.
And the final question for the night, this will be the last one that we take. It's from Dang. It says, where does the energy from tidal flexing come from?
Oh, that one. See, that one's one that you should know. Not you, but Dang. It's gravitational forces, obviously. The gravitational force of a moon circling a planet or whatever. The tidal flexing is caused by gravity. So, for instance, with Enceladus, going back to that, it orbits Saturn in a slight elliptical path. That elliptical path means that for part of its orbit it's closer, and for part of its orbit it's a little farther away than from Saturn. That's enough so that Saturn can flex that little moon on every orbit. So it goes in and out, flex, 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 and that can be just that's how that works. And it will generate heat, and it will generate that tidal flexing.
And there you go. And that is where we are going to end it for the night. I'm going to leave the cam on for a little bit, probably for another 5 minutes or so. But as for myself and Mark, we're going to wrap it up here. And be sure,
can I have that to go?
Once again, to get over to Mark's channel and subscribe. He will be hitting it up this week and doing some deep sky tours. You're talking nebulas, you're talking dual star systems, you're talking all kinds of just amazing stuff. And not only that, but you get a lesson as he is doing it. And it's a really good channel. I've been posting it in the chat, so if you want to go over and subscribe there, once again, he will be on, and we'll get the website figured all out so we can get everybody on the same page. I think it'll be really interesting.
Yeah, we're gonna have and thanks for that, Keith. I think that we show things that on the Sky Tour live stream. We actually show everything from star birth to star death. The beginning of a star's life to the end of a star's life. You can see it all, and I just I'm fascinated by all this. And as the summer wears on, there's a beautiful supernova remnant that we'll be able to see that's called the Veil Nebula. And I took a picture of it last time, and I didn't think it really came out too well. And then I started image processing it, and there it is. It's there, and I'm going to be posting it up on the Sky Tour Livestream Facebook page. Again, same name, so you can go like that page too.
And you'll have links to the Facebook page and everything in your descriptions of your live streams, where people can go get these images if they want them after the stream, or they might be up a day or two after, but you'll definitely get them up there.
Yeah.
And so
I will.
But yeah, if you guys want to check out something really neat and really different, really good cameras in the observatory up there, definitely a channel you want to subscribe to, and definitely one if you want to be educated a little bit. I'll pop in there sometimes. Sometimes Bill will pop over. So
we'll
never
get
know.
Paul in there too.
Yeah, we're definitely going to get Paul in there as well. So once again, I will say to make sure to thumbs up this video, because that does work in our favor for YouTube analytics. That helps get the word out and actually puts us next to a lot of other astronomy sites. So once again, thumbs up the video if you love what Paul does, and he was on fire tonight.
Yes, he was.
Getting these images and really doing a really awesome job. So once again, I'll post a link one more time for Mark's channel in the chat, and you can go subscribe there. We do have Amy Title coming up. We thought it was going to be tonight, but I think that was my mess up. I didn't get to actually email her until this morning.
4 a.m.
Yeah, 4 a.m. this morning. I'm messaging Amy Title about going on for a stream.
Wow.
But so yeah, but she'll be coming on. Fraser Kane will be coming on in a little while. So yeah, we got a lot of stuff coming up, and not to mention the talks are back on about that special guest that we were going to have for May.
Yeah,
that we didn't work out on. So I do have some news on that, or I hope to have news on that in the next couple of days as well.
I'd like to be around for that.
I know, and I will make sure that you are. So once again, ladies and gentlemen, we're going to cut it off here. I might just throw on a couple tunes into the end for a couple minutes, and then we will probably see you tomorrow. We are doing a solar stream at noon. So if you guys want to see the sun and you want to see if there's any action going on there, we'll be doing a solar stream at around noon Eastern Standard Time, being that we all get enough sleep, which obviously that won't be a problem since it's only 1:30. So all right, we will see you guys tomorrow. And Mark, thank you once again for educating the world.
It's just, I just love it.
Yeah.
Yeah. How can you,
I love it.
If you love it, you love it.
Yep. Always learning something. All right, ladies and gentlemen, we will see you tomorrow. Everybody have a good night and be safe.
Thanks, everybody. We'll see you later.
See you later.